Hello and welcome to this comprehensive SQL course for beginners by MindMajix. I am thrilled to have you join us in this journey into databases and data management. In today's data-driven world, SQL is the bag management. A recent analysis revealed that SQL is the most sought-after programming language in 2024, surpassing even Python in demand. Mastering SQL opens door to multiple career opportunities. In the United States, the Bureau of Labor Statistics projects on 8% increase in demand for roles such as SQL developers and database admins. Throughout this course, we will cover essential topics including database fundamentals, SQL syntaxes and queries, data manipulation, and advanced SQL. By the end of this course, you will have a solid foundation in SQL, empowering you to manage and manipulate data effectively. Before starting, if you have not subscribed to our channel, then please subscribe to our channel. And if you have any questions, feel free to comment below. We will answer all your questions. And if you want to learn SQL Server, our certified technical trainers will make you work on real-world datasets to help you get Microsoft Azure SQL certification and well-paying job roles like SQL Server developer, database developer, and others. Link in the comment section. Without any further delay, let's get started.
Hey guys, welcome to this SQL tutorial. In this tutorial, we are going to talk about how we can work with a SQL Server, and we'll see all the components of the SQL Server which are very useful in manipulating or querying the data which is saved in the database. But before I start the discussion, let's see the agendas that we're going to cover for the next few sessions in terms of understanding the SQL Server basics. The things that I'm going to cover in this particular tutorial is related to database management system, installations, type of database architecture, introductions, SQL, tables in SQL. We'll see how we can work with the various SQL command like create, use, drop database. I'll also talk about the data type in SQL, what are constraints, how relational database plays an important role, and the work of primary and foreign key. Apart from this, there are a lot of other topics that I'm going to be a part of this discussion. I hope you will be benefited by the end of this particular discussion, and you can work extensively with the SQL Server, and you can query any data from the database, and you can get the desired result of the output. Now, what is a database? A database is nothing but an organized collection of data stored in an electronic format. Now that sounds quite technical, right? It's nothing but the data that is collected around us through various types of source, like various types of business, whether it's a digital business, whether it's a business related to any product, customer, or service. The data is captured in a various format. Now when we organize this data in an electronic format, we call it a database. Now that electronic format follows various rules and regulations, various types of permissions and authentications to save the data in that particular format. To take care of those format and permissions and authentications, there is a software which takes care of creating and managing the data that is saved in an electronic, and that particular software is called Database Management System. And SQL is one such software which helps to create and manage the data that is saved in the database in that electronic format. Now every database has an architecture. Now let's understand what is the architecture. Database architecture are divided into two forms, the file server and the client server. Now what is a file server? A file server can be best explained in a way. Suppose you have an Excel file and you have shared your Excel file to your friend. Now if you do any changes in the Excel file, the original Excel file, the change cannot be seen by your friend. In a file server architecture, the computer or the server act as a storage device where the storage device can be accessed by only one person at a time. So file server architecture is a process, or you can say an architecture, where the system or the computer or the server act as a storage device. Now what is a client server architecture? A client server architecture can be best explained by this particular image where you can see three client server in the left hand side, or you can consider it as a client system or the end user system, and The system which is in between can be considered as a network system which is interacting with the database. Now let's understand this client-server architecture with the help of a very simple example. Now suppose there are three users who are accessing the IRCTC website. Now these three computers are the user computer where they are querying or they have requested to know the timings of a particular train. Now when the request is generated by its end user computers, the network computer processes that request and fetch the information from the database and provide it to the end. Now over here there can be n number of end user. Now this particular network server which is between the end user and the database process each and every query, and the database simultaneously takes the request for each of the users and sends the required query in terms of the request made. Now this was the client-server architecture. Now let's come to the important part for which this particular discussion has been started. Now, in order to take care of these queries, we use language, and SQL is such a language, you can say, or you can say such a software which interacts with the database. Now SQL stands for Structured Query Language, which is used for accessing and manipulating the data. So SQL is a software which helps to talk with the or interact with the database and helps to access or manipulate the database, which is available in the form of tables in the database. Now what is a table? A table is a database object which comprises of rows and columns. A table is always in a tabular format which is made up with some rows and columns. Now a table has two important components. One is record and the other one is field. As you can see in the image, a record is an individual entry of a table, and a field provides a specific information about the data in the table. To be very precise, a record is a single entry or a row, and the field is a value that is available in a particular column. Now we use certain command in SQL to interact with the database. Now there are four important commands that we deal with. The first is the data query language. The second is data definition language, and the third is the data manipulation language. Fourth is data control language. Now these four important commands are used for interacting with the table and the data that is stored in the database. Data query language like select, data definition language is used for creating, altering or dropping the table structure. Now to manipulate the data in the table, we use the data manipulation language, which is like insert or updating the table data or deleting the table data. And the last one is related to the data security, where we work with the concepts like permission or authentications which are allocated to the end user or the person who is going to work on the database. So this was the basic of SQL that we need to know for this particular session. I hope you have learned about a good idea about the basics of SQL and what are the things that we are going to talk about in the upcoming sessions. In my next discussion, I'll be talking about a detailed process of as how we can install a SQL server into our system. Different types of data types that we use in SQL Server. In SQL Server, we use three main kinds of data types: the numeric, character, and data type. Now let's understand what is there for each of the data type that we can handle the queries. So why we need data type? Data type actually states the type of data the particular record or a table contains in a database. Data type is a very common term in technical field where people working with different types of programming language or any backend scripting, data type holds a very important place over there. Now, talking about data types in SQL, it defines the type of data a particular column or a particular record in a table can handle. Or is a record the data type particularly shows the what kind of data a particular record or a column is holding. To start with, the first data type is numeric. Under numeric data type, we deal with big int, small int, tiny int, and decimal. When you talk about numerical data type, we have a different section of capacities for each of the data type, a range that has been defined for each of the data type. Now, if you can focus on this particular type of the screen, you can see for big int, the range starts from somewhere around -2, -92.2 plus 92337 and go on. So this is the maximum number of range, the maximum value that this particular data type can hold. Similarly, we have int, we have small int, tiny int, and decimal, which holds different types of data type in terms of value of the record that contains or the column type by which the data type has been defined. The next data type is character data type. Now, any data type which takes care of the text value or the string value in your table are called character data type. Now, under character data type, we have three important kinds of data type. First, char, varchar, and text. Now, if we talk about the char and the varchar is the most common type of data type that we use in our table operations. Now, it's very important to understand the difference between char and varchar kind of data type. Now, in char, you can see the range is 255 characters, and the same range we can see for varchar also. Now, the question is, what is the difference between char and varchar? Now, let me explain you the difference with the help of an example. Now, char data type is somewhat works with a static memory allocation. For example, if you define char 30, that means, and you supply a value of 2 or 3, that means in that case only 3 memory will be used out of the 30 memory size that has been allocated to the char data type, and the rest 27 memory blocks will be, or the memory allocation will get wasted. But the same thing if we do through varchar, if we define our data type as varchar 30, then even though you have been allocated 30 blocks of memory, and if you use only 3 blocks of the memory, the rest 27 doesn't get wasted. Only 3 block of memory will be in use. So a char data type is a static data type, you can say, it works on a static memory allocation, and a varchar data type works on a dynamic memory allocation. And similarly, we have text, which has a memory range of, it can hold a capacity of 65,535 characters. The next is date and time. So we have three important type of data type in terms of date and time in SQL. So we have a date, time, and text. The date holds the date format in the form of year, month, and days. The time holds the format in terms of hour, minutes, and seconds. And the text holds the format in terms of years. Now, it's very important that you should understand where, when, and where we have to use the date data type, because date is related to the time component in your table. So it should be used very carefully where you are dealing with some time aspect of the data. Apart from data type, there's one more important thing that we deal in SQL, that is constants. Now what are constants? Constants are nothing but the limitations that we use in a table in SQL. There are mainly 4 kinds of constants: not null, default, unique, and primary key. Now, talking about not null, when we define a constraint as not null, that means that particular column cannot hold a null value. Default stands for an option where we need to give a default value for a specific column. Now, for example, if I'm making a table and if I set the employee age as default to 25, that means that particular column in the table will always hold a 25 as a value. Unique means a column in a table will always hold a unique value. It cannot hold a duplicate or ambiguous values. And primary key is the combination of not null and unique key. Means a column which has been marked as primary key in SQL cannot have a null value, and all the values in that particular column should be unique. The next thing that I'm going to talk about is relational database, the most dominant database model in SQL or database world. Now, relational database works on the concepts of tables. where we use structures that allow us to identify and access data point in relation to another data point in the database. Means data in a relational database are organized in the form of tables. The relationship that can be created among the tables enables a relational database to efficiently store huge amount of data and effectively retrieve the selected data. And that's the reason that relational database is the most dominant database model in the database concept, because it is the design of a relational database allows you to work with multiple tables, and as a result of which we can effectively store a good amount of data in a structured way, and we can use queries to retrieve those selected data. Now we follow certain process while designing a relational database. The first thing that we need to take care is we need to define a purpose for the database. Then we have to gather the data and organize the tables and specify the primary keys for the table. Now in my upcoming sessions, we will clearly see how we can work with defining a primary key, working constraints and options. And after we are done with gathering and organizing the data, we need to create the relationship between the tables. There are mainly three key relationships that we work in a relational database. First is one-to-many, many-to-many, and one-to-one. Next, we have to normalize the design of the table. A relational database allows you to normalize a design of the table. And when we say normalization, means we can add more columns, create new tables, and we can split a large table into smaller tables. Now when I talk about tables in SQL Server, in tables we work with two important constraints. First is a primary key, and the second is a primary key is used to ensure the data in a specific column doesn't hold a null value and should be unique in nature. Whereas a foreign key is a column or a group of columns in a relational database that provides a link between the data in the two tables. It's a column that references a column from another table. Now let me explain it with the help of an example. Suppose you have an employee table and a department table. An employee table, the employee ID column is a primary key, and in department table, the department ID column is a primary key. Now, for any reason, for a specific reason, if I use the department ID column in the employee table, then that particular department ID column is a foreign key for employee table, which can be used for establishing a connection between the employee and the department table. So this is the concept of primary and foreign key. Now in my upcoming discussions, I'll be discussing about every concept starting from data type, constants and keys in detail. I'm going to discuss about the various SQL commands. In my previous videos, I have explained you about how we can install SQL Server and different types of options that we have in terms of data type, constants, and how those constants plays an important role in working with SQL Server. In these sessions, let's dive into some practical examples and let's dirty our hands with some queries and see how we can work with the different SQL commands. So when I talk about SQL commands, there are 4 different types of command categories that we use in SQL. It starts with data query language, then I'll talk about data definition language, the data manipulation language, and the data control language. Under each of the SQL commands, we have different types of commands that we execute. As you can see on the screen, for the data query language, we use the select command, the most powerful SQL command and the most frequently used SQL command that we have in SQL Server. The next is the data definition language, where we use commands like create, alter, and drop command. Now, the most important feature of the data definition language is that with the help of create, alter, or drop table command, we actually work on the structure of the table. And then we use the data manipulation language to work on the content of the table, like inserting a new value, updating a new value, or deleting an existing value. And then comes the data control language, where we work with the commands like grant and revoke Now this data control language actually focuses on giving authentication or authorization to the end users or the users of the SQL Server. So let's see how we can work on some hands-on examples to understand these concepts of the various SQL commands. Now for this example, what I have decided to work on a database, or we'll see how we can work on a database or how we can create a database and a table under that particular database. So during this particular example, I'll show you on a hands-on basis as how we can implement this kind of SQL commands. So let's see. Now for this, what I can do, let me initialize my SQL Server Management Studio, which I have discussed in my previous sessions, where how to install it. Now over here, what I will show you how we can work on an existing database and also how we can create a new database. So these are the first things that we're going to talk about in today's agenda. I'll talk about how we can create a database, a table under that particular database. We'll also see how we can use the commands like insert, update, alter table, alter column, how we can duplicate a database, how we can drop a database, taking a backup of a database, restoring a database, and also renaming a database. Now while doing all these kinds of topic or discussing about all these kinds of topic, I'll show you some hands-on example for each of the topics that is stated over here. For this, let's go and let's initialize our SQL Server Management Studio and let's see how we can implement these agendas for today's session. So I have fired up my SQL Server Management Studio and this is the login screen which I have initiated. And I'll click on connect over here and my server has started, has initialized. The first thing that I want to do over here is to restore a database. Now the database that I'm going to restore will be the database which I will be following throughout the discussion. I'll be working on two important databases. The first is AdventureWorks 2019 and the second one is an HR database. Now let me first restore the database and let me show you how we can restore a database once we install a SQL Server Management Studio. Now to restore a database, what we need a database copy. Now these are the copy of the database. You can see the AdventureWorks 2019 and the Human Resource database. Now database backup has a format of .bak. So you can see the format of this two databases is .bak. Now what you have to do, you have to copy these two database instance which we have, or the copy of the database, and I'll go to my C drive. In C drive under program files, now if you can focus on this particular area, this path area, you have to go to the program files in Microsoft SQL Server folder. Under that folder you have to click on the server name, the star server that I have created. Under the star folder we have the MySQL folder, and under this MySQL folder we'll have backup folder. In this backup folder you have to paste these two database over here, and we have to go to the SQL Server Management Studio and you have to right click on the database over here. Now when I right click on this database after I initialize my SQL Server Management Studio, I'll get an option over here called Restore Database. When I click on Restore Database, this particular pop-up menu will come over on your screen, which have three categories: the general, the files, and the option. When you click on device, you have to click on this particular device. You'll get this option over here on these three dots. You click on this three dot, again you have to click on add, and you can see those two databases which I have copied in the backup folder. You can select the first database over here. Now remember one thing, you can restore one database at a time. You cannot restore all the database at one go. So to select the database over here, click on OK. Again click on OK. You can come to this database folder option, the destination option, and you can change this human resource database name into HR database. You can come to the file. In this particular page or in this particular step, cannot do any changes over here. Then you have to go to the option, and over here you can check mark this particular option, override the existing database, and you can click on OK. Now the moment you click on OK, you'll get a message over here on your screen as database HR has been restored successfully. And now to see the effect of this restore, you have to right click on this database folder, click on refresh, click on this plus sign, and you can see the database over here. In the same way, I'll restore the AdventureWorks 2019 database into the SQL Server Management Studio. I'll do a right click on the database, click on restore database, select device, click on add, select AdventureWorks 2019, click on OK, and then you have to come to the option, check mark this, click on OK, and you can see the AdventureWorks 2019 database is also restored successfully to the SQL Server Management Studio. Now that I have restored two databases, the HR database and the AdventureWorks database successfully, let me start working on the various SQL commands. The first thing that I'm going to do over here is to create a database. Now for that, I'll go into this new query option, click on it, and there will be a new, you can say a new window will come up or a new screen will come up. Now this particular screen is the place where we write and execute all the SQL commands. So this will be the area where we'll be working in most of the time in our SQL discussion. So what I can do, I can write the first command to create a database, and it's very simple. I just need to write create database, and let me name the database name as d underscore tably. Now to execute this particular query which I have written, the output of this query will return me a database. Now there are few ways how we can execute a query. Either you can click on this execute option, or you can press F5, or the most common way that I do is you can select this particular query from your keyboard, press Ctrl E. I can see there's some error over here. Let me see what is the issue. Okay, so this particular name already exists. So let me give a database as Lucifer, and let me execute it, and you can see the command has successfully executed. So we have just created a database with the name Lucifer, and to see the effect of this particular database command, I can right click on the database, click on refresh, and you can see there is a database created d underscore Lucifer. Now that we have created a database, we have to tell the SQL Server Management Studio that we will be working on this particular database. Now if you can focus on this particular area, you can see at present it's showing us AdventureWorks 2019. So the current database which is in use is AdventureWorks 2019. But for us, we have to work on this particular database, because I'm going to create a table under the d underscore Lucifer, and we'll also see how we can create a table and a column under the database over here. Now to do that, we have to tell SQL Server Management Studio that I want to use this particular database for creating a table under this. So again, we'll accomplish this particular task with a query. So I'll write use b underscore, and you can see the drop down the database name has already appeared. So we'll select it, and again press Ctrl plus E, and now you can see the name has changed from AdventureWorks 2019 to d underscore Lucifer. Now that I have created a database and I have initialized that particular database, let us quickly create a table under this. So what I can do, I can write create table emp data. Now whenever we are working on creating a table using the standard SQL commands like create table, you can see these are all data definition language which is actually affecting the table structure. So we can see the create table emp data over here, and whenever we are creating a table over here, we have to always mention the first column of the table. Now how to do that? We'll open a bracket and we'll write the first column name as emp id, and the column type will be, and we can close the bracket. And now if I execute this particular query, a table has been created under the database d underscore Lucifer, which has an empty column as emp id. Now I can do a right click over here on the database name, click on refresh, and now if I open this particular, expand this particular database, under the table folder, you can see there is a table created, that is emp data. And under this emp data, If I expand the column folder, you can see the EMP ID column has been created. I can also see the table structure by using the right click option and selecting the design option from the drop down. And you can see the design of the table where you can see the table name and the column structure or the column design of the table. So this is how we can use some of the data definition language or the SQL commands you can see you can use while creating. Now that we have created a table, let's insert some values inside that particular table. Now how to insert a value inside a table structure? Again, we'll use the SQL command that we have, the insert command, for inserting some values into the table. So for inserting, what I can do, I can write insert into table name, that is EMP data. So I've specified the table name where I am to insert the data, and now I'll specify the column names in which I want to insert the values. So the column names can be inserted as EMP ID, comma, and also I can mention another column name over here within the bracket, EMP name, and I can close the bracket. I can also drag the column name. So instead of writing the column name, what I can do, I can drag the EMP ID over here and I can release my mouse. And now I'll insert the values over here. For inserting the values, I'll write values within the bracket. For employee ID, I can give 112, and for the employee name, whenever you're using an employee name, means we are going to use a text value. So and that should be within the single quotes, and we can write as Williams within the single quote, and you can close the bracket. Okay, so I have not defined the column name, employee name over here. So let's remove this column name over here, and let us first execute this part of the value. And you can see that for employee ID, I have supplied a value using the insert command, which states over here is 112. And you can see as a result of this particular query, one row has been affected over here. Now to see the change in the table, how the data is showing in the table, we can write one more command as select star from the table name, that is employee data. And if I execute this query, we can see for employee ID, we can see the value 112, which we have just inserted using the insert command. So we can see that how we can use the SQL commands to manipulate the data, how we have used the SQL commands to create a database, create a table under that particular database using a column, and how we have used the insert statement to insert a value into the column. And then we have used the select statement to fetch the data from that particular table. So this is the type of queries that we write on a day-to-day work, and this is how we work on the table which is created under the SQL Server. Now one interesting thing that I want to talk about over here is we have used the select star from EMP data. Now what we can see, this star actually symbolizes all the record. So whenever we use a star symbol along with a select statement, what it will do, it will select all the records from the table. So star over signifying means all the data from the table. So let's see how we can take up the next important command, that is our update command. Now if you consider the update command, this command is used for data manipulation. So it comes under the SQL command, that is data definition or data manipulation language. Now the scenario is I want to replace this 112 value that I had just inserted into the employee ID column with a different numerical value. Now in this example, through update command, I will talk about what is the best practices of writing a SQL query first, and second, how we use a data manipulation command to update any particular record in a table. So let's see how we can do that. So to update it, we can write update. I'll take the cursor to the next line. Let me increase the font size a bit. So we can write update table name, that is emp data, and again going to the next line, we use the set keyword. Set column name emp id equals to 100, and over here we'll use the where clause. So we'll just take some space where emp id is equals to 112. That's it, we are done. So what you can see, let us break this particular update statement or update query, and let's understand the things that we have used over here. The first is the data manipulation language, which is actually manipulating the table emp data, where we are using a set keyword. Now set, what it does, it actually updates an existing value with a new value. Over here we are setting the emp id column where the column value is 100, and we are using a where clause. So where actually defines the condition. So over here the condition is where the emp id is equals to 112. Now if I execute this query, you can see that one row has been affected. And now again, if I execute the select statement, now this time you can see in place of 112, we are able to see the 100, the new value that we have updated. So this is how we use the update command to update a value in the table. So we can see that we have used a update statement to update the value. Now till now I was working on a table which was consisting of a integer value. Let's create a table where we can see how to work with text values. So I'll take a new query for this, and I will quickly write a command like create table name as table, create table t underscore, let's give me the name of the table as here product, and I can write the product name as a column, and let me define the data type of the column as varchar, and let me set the value of the varchar or the range of the varchar as 30. So what I have done, I've created a table product with a column that is product name, which is a data type of varchar. Now if you remember, I have discussed the data type in my last video, where I have discussed the difference between varchar and char. Now what does varchar do? Varchar allocates a dynamic memory, whereas a char allocates a static memory. So now if I select this particular statement and if I execute it, you can see the command has been successfully executed over here. And now if I refresh the database Lucifer over here, and on the table section I can see one more table has been created. Now this time this table consists of a text value. Let us see how we can insert values in this particular table which are text in data type. For that, what I will write, insert into table name, that is t underscore product. I'll define the column over here, that is p underscore name, close the bracket, go to the next line, and you can write values. Now this time, in order to insert the text value, we'll be using a double or single quote. So I'll write pro underscore 1 or pro 1 over here, and I'll close the bracket. Now what I can do, I can select this particular statement, press Ctrl E over here, and again I'll use the select statement to see whether I was able to successfully insert the value under the t underscore product table or not. So I'll write select start from the table name, and over here the table name is product. I can select this particular statement, I can execute it, and you can see that I have successfully created a table which can hold text value. And one important takeaway from this example is you have to always mention the text value within single quotes, and that's a very important thing that you should be keeping in mind. Whenever dealing with text values, you should always use it within the single quotes. The next example that I'm going to talk about is how we can alter a database. Now, one important thing that we need to keep in mind altering a database is that we cannot alter a database which is currently in use. So if I want to alter the database name as D underscore Lucifer, we cannot do that because D underscore Lucifer is currently in use. We can only alter the name of a database where the database is not in use. Let's see how we can do that. What I can do, I can come to the next line and I can write alter. So I'm again using one more SQL command over here. Alter database. Let me give the name of the database as Adventure Work 2019. So I can drag this database name over here and we can write as modify name as equal to, let me give it as Adventure Work 2019. And if I select this particular command, if I execute it, you can see the database name has been changed. Now to see the effect, what I have to do, I have to come and I have to refresh this database folder over here. And you can see the name of Adventure Works 2019 has been changed into advworks underscore 2019. So this is how we can use another data manipulation command or you can say statement under the SQL command which can be used for altering or modifying the database name. The next example that I'm going to talk about is how we can alter a table. So we have seen how we can alter a database, right? Now to alter the table, I'll go back to my previous example of employee data and I'll write a command over here as alter table name. So I'll write the table name over here as emp data, or what I can do, I can bring the table name from here. Now what I want to insert a new column into this particular table as a part of my alteration, and that particular column should have a special feature. Now what is that particular special feature? That any data that comes into that particular column should have an auto increment. Now, for example, the scenario is, for example, we have an employee ID 100, and now if I insert a column as, so we'll use add pro ID as a new column and the data type should be int over here. Now this particular pro ID column whose data type is int, I want that any data that comes into this particular column pro ID should have an increment of 5 each time a new data is inserted. If the first data is 1, the next data should be an increment of 5, that is 6. Now how we can achieve this kind of scenarios while altering a table? So we can use a word called, we can use a clause called identity. Now how to write that? We'll simply write identity and within bracket I'll define the first initial value, that is 1, and second initial value as an increment value, and you can close it. And now if I execute this particular statement, you can see this command has been successfully inserted. And now if I use this select statement again, you can see beside employee ID, the pro ID column has been inserted and the value is 1. And next time if I insert another value, for example, if I repeat this particular, copy this query, and this time I insert 113 as employee ID, and if I execute this query, and again if I execute the select statement, you can see as a part of this identity command keyword that I have used over here, the next employee ID is 113 against which the product ID is 6. So this identity actually is adding an increment value where the value starts from 1. Each time a new value is inserted, the increment will be in terms of 6. Now again if I insert a new value to this particular table like 114, now if I execute it, and again if I execute the select statement, you can see 6 plus 5 11. Now this is how we can alter a table, but I have showed you an example with a real life scenario where we want product ID to be allocated to each of the employee ID with the increment of 5. The next example that I'm going to talk about is how we can alter a column. For that, let me go back to my previous example where I have defined a table T underscore product with a column name as P name varchar, whose range of value is 30. Now we have seen how we can alter a database. We have seen how we can alter a table. But now we will see how we can alter a column in a table. Now to alter a column, let's discuss a scenario. What I want for this particular table, T underscore product, the column name P underscore name, which data type is varchar, I want to reduce the value from 30 to 12. So instead of defining the varchar range as 30, I want to reduce it to 12. So over here what I'm doing, I'm actually altering the column over here. So what I can do for that, I can write a simple query as alter table name. I can bring a table name from here. Again, I'll come to the next line and I'll write alter column column name. So let me bring the column name over here as P underscore name, or I can drag column name from here. So I can write column name over here. So I can write P underscore name, and this time the varchar, I'll define it as 12, and I can close it. But before I execute this particular statement, let us first see what is the actual value of varchar over here. We can see the P name underscore name. P underscore name is having a varchar value as 30. So what I want, once I execute this particular statement, it will reduce to 12. So I can select this particular statement, press Ctrl E, and you can see the command was successfully executed. And now, if I refresh this particular table, and if I come to the column, you can see the varchar value has reduced to 12 from 30. So this is how we can alter a column in a table. So we have started from altering the database, the table, and the column, and we can alter the column to the detail of modifying the data type of any column by using the alter. The next topic that I'm going to talk about is how we can create a duplicate database. Very interesting topic. To create a duplicate database, what I can do, I can just come to this particular database, and what I want to create a database, a duplicate of a database called D underscore Lucifer. So what I can do, I can come to this new database, right click on this database folder, select new database option over here, and let me give the name as D underscore Lucifer underscore copy, and I click OK. Now the moment I click OK, you can see a copy of a database has been created. Now that the copy is created, the next thing is that I want to copy all the tables and data from this D underscore Lucifer from D underscore Lucifer to D underscore Lucifer underscore copy. For that, I'll do a right click in the duplicate database, that is D underscore Lucifer underscore copy. Go to task option, and over here I'll select the import data option. Now this particular wizard will open of import and export wizard. I'll click on next, and from here I have to select the option that is SQL Server Native Client 11.0. In the server name, I have to give the name of the server as MSI star /star. You can see the same server name over here. In the authentication, you can select the level of authentication that you have given while installing the SQL Server. From the database option, I have to select the source database, that is D underscore Lucifer. I'll click on next, and again I have to choose the destination database. So I'll again select the destination. For this, I'll select the SQL Server Native Client, and you can see the server name has been automatically updated for the destination database, and you can see over here the destination database is D underscore Lucifer underscore copy, and again you can click on next. In this particular section, we'll keep the copy data from one or more table or views option as checked, and then we'll click on next, and I have to select the data or the table which are available in the source database, and you can see there are two tables, emp underscore data and t underscore product, available in the source database. So you can select it, click on next, keep this screen as it is, no changes required for this particular save and run package screen. Click on next, no changes required over here also, and then you can click on finish to initialize the process, and you can see there are three rows from the emp data and one row from the t underscore product has been successfully imported from the source database to the destination database. You can click on close. Now if I write a small query over here, let me take a new query over here, and let me select the copy database from here, and if I write a select statement as select start from D underscore Lucifer underscore copy, and if I execute it, okay, so I have to write select emp from emp data. So I've given the database name, but mistake, it's fine. So we have to give the table name over here, and if I select the table name, and you can see the table emp data is showing us all the data from the database called D underscore Lucifer underscore copy. So this is how we can copy a duplicate we can create a duplicate of a database. Now there can be various reasons for duplicating a database, maybe due to security issues or maybe taking a backup of a database. But this is how we we create a duplicate database and we input all the required tables and data from the source database to the destination database. The next example that I'm going to talk about is how we can drop a data. Now again, we cannot drop a database which is in use. So over here we can see d underscore lucifer underscore copy is in use. So we cannot drop this database. Now for example, if I select another database like d underscore lucifer, and now if I drop the database as drop database d underscore lucifer copy, and if I execute this statement, you can see the command has been successfully executed. And now if I refresh the database folder, you can see the d underscore lucifer underscore copy has been dropped from the server. So this is how we can drop a database from a server. So keep one thing in mind, that you cannot drop a database which is in use. So you have to always drop a database. You can always drop a database which is not currently used for querying your request. The next thing that I'm going to talk about is how to take a backup. So I have shown you how we can restore a database. I have shown you how we can drop a database. Now I'll show you how we can take a backup of a database. For example, if I want to take a backup of this particular d underscore lucifer, I'll do a right click over here, go to task, select backup option over here. From here, I'll select the database as an option. We have three options over here: general, media options, and backup option. I'll select the database option over here and I'll keep the database type as full. This is the path where the backup will be stored. So you can see in the backup folder, the same folder from where we have restored the database, the backup of the database will also be added to that particular folder itself. From the media option, I will change the override media to override all existing backup sets. So whatever backup will be taken, the recent changes will override the old changes and a fresh copy of the backup will be stored. From the backup option, I'll not change anything from over here and I'll click on OK. And you can see the backup underscore the data d underscore lucifer database has been successfully backed, has been stored. Now to see the changes, we'll go back to the backup folder in our C drive. And you can see the d underscore lucifer.bak format has been restored or backed up into the backup folder. So you can go to this particular path and you can check whether your file has been properly backed up or not. So this is how we take a backup of a database. So this is how we can work on some of the aspects of SQL Server. In today's session, I have shown you how we can use some of the SQL Server commands. Now for my next video, I'll be discussing each of the SQL command in details, and I will start the discussion with select statement. Now I'll show you a good amount of hands-on examples as the various uses of select statement in SQL Server.
Select statement is a data query command of SQL Server. The select statement has a very detailed implementation in the SQL Server domain, and in today's session I'm going to talk about those implementation. Now before I proceed with the hands-on examples and get into action, let us first see what are the topics that I'm going to talk about in terms of the select statement in SQL Server. When we talk about select statement, today I'm going to talk about how we can implement select with from, clauses like where, operator like and or, how we can use the select statement with in, between, how we can use the select statement to check for the null values, how we can use a select statement along with an alias, how to find a distinct value from a set of data using a select statement, how we can use as with select, how we can sort our data using a select statement, and we'll see the uses of case, year, and some time intelligence component or time component along with the select statement. Now, as I said, select statement is a data query language or data query command you can sub-SQL. It's the most powerful command we use in SQL to extract the data from the table. Now, select statement is the most commonly used statement in SQL, but it has lot of implementation in terms of conditions, operators, functions, alias, data management. And in today's session, we are going to see some of the implementation in terms of the select statement with the other constants or components of SQL Server. So let's jump into the action and see how we can use this select statement in various forms. In my last video, I showed you how we can restore a database. So for today's session, I'm going to work on this AdventureWorks 2019 database that I have restored yesterday. Now what I can do, I can click on new query, and what I can do, I can first initialize the database, or first getting connected to the database on which I'm going to work. So I'll write use ADVWorks 2019, and now I'll execute this statement, and you can see the ADVWorks 2019 has been updated over here. Now let me write a very simple query using select, where I'll be working on a particular table in this AdventureWorks 2019 database. So I'll click on this plus sign, and in the table folder, if I expand this particular folder over here, I can see there are number of tables which are listed under this particular database. Among this table, I will be selecting the human resource dot employee database, or table, sorry. Now human resource dot employee, what I can do, I can write a simple statement over here is select star from human resource dot employee. Now you might be thinking, what is this human resource and how we are accessing the employee table using this human resource option. This human resource is nothing but a schema. Now I'll be discussing about how we can create schema in SQL in my upcoming discussions. But for now, you can say schema is just a structure of the table under which we define the other tables related to that particular structure. Or you can say schema is a segment of a database under which we define various type of tables. So under the schema human resource, I am working with the table employee. And now let's see what happened when I execute this particular query. And as I said, there are three ways to execute a query. Either you can use this execute option, or you can press F5, or you can just use the Control plus E option. And we can see that this select statement along with the star icon or the star symbol, which symbolizes all the records from the table, has fetched all the records from the employee table, which is created under the human resource schema. And we can see over here that this particular employee table consists of columns like business entity ID, national ID number, login ID, job title, birth date, material status, and all the employer related information. Now this is the most basic implementation of select statement, which is followed by a star symbol and a from keyword. Now what if I want to associate a condition with this select statement? For example, what if I wanted to know, or I wanted to fetch only those data where the gender is equals to male? Over here we can see there is a gender column in the table. Now what I want to fetch only those data where the employee gender is equals to male. Now before I proceed forward, whenever we are working with a condition in SQL, we have to use the keyword called where, or you can say we have to use the clause called where. Now where clause allows you to define the condition within the query. It holds or it states the condition under which the particular query will be executed. So how we can define a where over here? So the requirement is that I want to fetch all the record from this particular table employee where the employee gender is equals to male. So I'll come to the next line and write where gender is equals to male. Now what I have done, I've defined the condition. Now if I execute this particular statement, you will see that I have got all the records which is selected with the star symbol where the employee gender is equals to male. Now what if I want to work with multiple conditions under the where clause? Suppose I wanted to understand or I wanted to know about the vacation hours of the employees. So there's one column over here stating the vacation hours in terms of the employees. Now I wanted to get a information where I'm looking for those employees whose vacation hour is more than 40. So there might be any compliance in the organization where an employee, if the vacation hour during a specific period is more than 40, then there will be some set of rules applicable for that particular employee. Stating that particular condition in mind, let us find out the employees who are male but have a vacation hour more than 40. So for this, what we have to do? We have to work on multiple conditions. Now, whenever we are working with multiple conditions in SQL Server, we have to use certain operators, certain logical operators, certain greater or less operators. Now, over here, what I can do, I can modify this particular query and we can add more information as select star from the employee table where gender is equals to male and vacation hour is greater than 40. And now if I execute this statement, you'll get all the male employees details where the vacation hour is more than 40. Now what if I want to extract certain particular columns from the table in terms of the specific condition or in terms of the stated conditions in this query? Now suppose I am interested to know about some specific columns in the table. I don't want to fetch the whole data using the star symbol. I wanted to know the job title. I wanted to know the material status. I wanted to know the, you can say, vacation hours of the employee where the employee is male and where the vacation hour is more than 40. So what I can do, I can remove this star, I can bring the from in the next line and let us state the columns. So I want to fetch the job title, comma, I want to get the material status of the employee and I want to know the vacation hours column also. Along with this, let's also get the let me check what else I can get from here. Okay, so let's keep this particular information to 3 columns. Now what I have done, instead of fetching all the values from the column, I have selected 3 columns from the employee table where this specific condition has been mentioned. And now if I execute this, you can see that I have got the job title, the material status, and I've got the vacation hours as per the stated conditions over here. So you can see I started with a very simple select statement and then I have added more and more conditions and have made the select statement more and more specific in terms of the requirement. The next thing that I wanted to work on is if you focus on this vacation hour column, we can see that the data in the vacation column is not sorted properly. What if I want to sort the order or sort the vacation hours in terms of the descending order? How we can achieve a sorted data in SQL? We can achieve it by the order by clause. Now, for example, if I add order by clause in this particular existing select statement where I want to sort the vacation column in descending order, and now if I execute this statement, you can see that the vacation column has been sorted in descending order. Further, we can add more columns to it. For example, instead of male, let me add a gender column over here. And now what I want, not only male but also the female details in terms of the vacation hours. Now, how to get this kind of options where we are working with the same column but with multiple conditions? We can write it as or. So we have to replace the or with and again we have to write gender equals to female, and you can give a comma or you can just leave it like this, and we can see how this male and female works over here. We can also add an and over here, and now if I execute it, this statement, you can see that I've got a gender, male and female, the material status, the vacation hours, and you can see all the vacation hours over here. But wait, what I can see over here, even though I have able to fetch the male and female from the gender, but in the vacation hour, the specific conditions that has been stated in the query where the vacation hour should be more than 40, we can see the data where the vacation hour is showing less than 40. Now, how to work on this kind of errors? Now, this particular query is not actually giving an accurate result. Now, how to fix this kind of issue? Now, whenever we are working on this kind of issues where the data is not correct in terms of a specific conditions, we have to follow the concept of order of precedence. Now, what is an order of precedence in SQL? It's nothing but using the concept of PEDMAS. Now, in maths, we have learned the concept of PEDMAS where the calculation starts from the parenthesis, then it goes to exponential, then divisions, then multiplication, then addition, then subtraction. The same concept we'll be using over here in SQL, which is known as the order of precedence. Now, how we can implement the order of precedence? We just need to put a bracket around the gender, and now what will happen under the concept of or under the rules of order of precedence, the bracket will be executed first and then the vacation hours will be extracted. So you can just select this particular statement and you can execute it, and now if you can see the results over here, you can see that I have got an accurate result in terms of the vacation hours, and also I was successfully able to fetch the male and the female data over here. Now this is a very interesting concept of order of precedence. It is implemented in your day-to-day work where you're working extensively with the select statement, extracting multiple values from a single column. Now, what if I want to make this particular query more and more, what you can say, specific, and how we can make this query more and more short where we have to write minimum lines of query so that it executes faster and the performance of the query is more enhanced. Now, what I can do, instead of using two gender in one query, what I can do, I can use a in keyword where I can define the male and female both over here. So let's see how we can do that. So what I can do, I can remove this particular, I can use a comment over here, comment icon over here, and under gender where clause, I can add the gender column, and I can use an int statement after gender, and then within bracket, I can define the male and the female over here. And I can bring the and statement into the next line. And now if I execute this particular query, I'll get the same result. But the best way that I have used over here, instead of mentioning the gender twice, I have used the gender column once, and we have defined the gender male and female within the brackets over here. So this is how we can use a in keyword to make or to shorten our queries in order to increase the time performance or the performance of the query in SQL Server. Now what if I wanted to know the range values within a certain column? Now for example, I wanted to know the vacation hours in terms of starting from 40 and 50. How we can get this kind of conditions achieved through queries. So let me take a new query over here, and the requirement is that I wanted to fetch the data of the employees where the vacation hour is for between 40 and 50. So whenever you are working with a range within a specific column in your table, we'll be using the between keyword. So let's write a query for this. So what I can do, I can write select gender, so I'm going to write select from human resource dot employees, and let me select the columns. So what I can do, I can write select gender, I can write job title, vacation hour, from the human resource table where the vacation hour is between 40 and 50. And also let me sort the vacation hour column in descending order. So what I have done, I have actually defined the range in the vacation hour column, which should be starting from, which should be between 40 and 50. Now if I execute this particular query, I'll get the gender, the job title, and the vacation hours between 50 and 40 sorted in descending order. Now the takeaway from this particular piece of uh, query is that whenever we are working with a range, along with the select statement, we have to always go for this between keyword. And then we can define the range followed by the sorting command. Now this is the best way to work with a select statement where we are working with a range value in a column. Now what if I want to use the select statement to verify whether a particular column in a table contains null value or not? Now the requirement is that I want to use the select statement to check whether a particular column in a table has a null value or not. So I'll take a new query for this. I'll write select from table name, that is human resource dot employee. I'll select a column called business entity, and one more column let me select where I can write the organizational node column, and I'll check with the where clause where organizational node is equal to null or not. So how to write that? We'll write is null. So we'll use this particular expression over here. And now if I execute this particular query, you can see that there is one null value in the organizational node. Now to check that particular null value, I'll write select star from human resource dot employee. And now if I execute this particular query, you can see the organizational node contains a null value at the very first row of the column. So this is how we can use the select statement to check for the null value in your table data. Now there might be some situations in our day-to-day work with the SQL Server where we need to find a particular uh, value from the table where we are not sure about the whole structure of the value. Now let me give an example. Now suppose you are working with a employee table and you are searching for a particular employee. Now it's a normal human psychology that we tend to forget about the names of the person or name of the road or place. Now over here what happens, you are not able to recall the whole name of an employee, but somehow you are able to figure out or you are able to recall a part of the name of the employee. Now, in that case, how we can use a select statement where we don't know the full name of the employee, but we can remember few words or for a part of the name. So this kind of scenario we also resolve, or this kind of scenario can also be capitalized by the use of select statement. Now let's see how we can do that. Now for this example, I'll take a new query and I'll use the person table which is available under the AdventureWorks 2019 database. Now let us first see what are the contents of this particular table. So I'll write select star from person dot person, and now if I execute it, I can see this particular table contains the details of the person starting with a person type, title, first name, last name. Now, what is the scenario that I want to search for a person whose name is Terry, but somehow I'm not able to figure out the whole name. I can only figure out few words of the name, a part of the name like ERRI, but I'm not able to recall the whole name of Terry. Now, how can I use a select statement for this kind of scenarios? So I can write select, so I can remove the star symbol from here, and I can write select first name, last name from the person table where first name is like, I can write a single quote started with a underscore and then a single quote. So I can just figure out a part of the name over here, right? Now what I can do, I can select this particular statement and I can execute it. And you can see that the select statement has given me the whole name of the person, that is Terry Duffy, whose there is a first name and the last name is Duffy. So with this like keyword, it allows us to find a estimate, or it allows us to guess a part of the name, and the rest of the things can be taken care of by this like keyword. So it helps the user to extract the particular value from the table where the user is not sure or is not able to recall the whole structure of that particular value. The next thing that I'm going to talk about is how we can use a select statement to find a distinct value from a set of data. Now in every data there will be a repetition of values within a same column. There can be a customer name which can be repeated maximum times, or they can be repeated multiple times in terms of the transaction has done. Now the question is how we can understand who are the distinct customers in our data set using a select statement. So we can use a select statement to find the distinct values from a column. And for that, we will be using this person table where I want to find the distinct name of the persons in that particular table. So what I can do, I can write a simple statement. I select distinct keyword and I can write the first name. Or what I can do, let me select the first name. So I can write select from person dot person over here, and I can select the first name and I can write the distinct keyword in front of the first name. And now if I execute this particular query, I've got all the distinct name from the first name of the column. Now you can see there are 1018 distinct name available in this particular table. Now if I remove this distinct value from here and if I execute this particular query again, you can see there are 19,972 rows. If you can focus in the right hand side down corner of the screen, you can see there are 19,972 rows of values in this data, and out of which the distinct values can be calculated with this distinct keyword. So the distinct values among all these rows is 1018 rows. So we have seen how we can use a distinct value with a select statement. The next thing that I wanted to discuss is all about having an alias name. Now how we can give an alias name to a column by using a select statement. Now if you can see in this particular query, we have seen the column name as first name. Now what if I don't want to have this particular column name? Instead of this, I want to have an employee first name as column name. So how I can give a different column name using a select statement? Now we can give a different column name means we want to give an alias name to the column. Alias is a concept where we have alternative names for a specific value or a specific expression. Now to have an alternative value means allocating or assigning an alias name. Now in SQL we can assign an alias name with the keyword called as. And now if I select the distinct first name as emp underscore first name, and now if I execute this particular query, you can see the column name has changed to emp first name. So as is a keyword which allows us to assign a alias name to the existing column name. So this is how we can define a employee name or a first name as employee underscore first name. Now the next thing that I'm going to talk about is how we can use a select statement to extract a specific set of data from a given data set. Now for example, I want to extract the top 50 values of a specific table. How we can use a select statement for that? Now let me take a new query for this, and now suppose I come to another table over here. Now let me get a table like I want to get okay, let me take this particular table, sales order detail table. Now what I wanted to know the top 50 order quantity. Now if I right click on this particular table, I can use some predefined function of predefined option in SQL to extract the top 200 rows or top 1000 rows. So I can see there's an option over here, select top 1000 rows. Now I can see this particular query is selecting the first 1,000 rows from this table. Now, how we can make this particular data more dynamic? I don't want to go for 1,000 rows. I want to go for 50 rows. So how I can do that? I can write a select statement, select from sales dot sales order details, and I want to select the top 50 order quantity. And if I execute this particular, I have got the top 50 order quantity. So top is the keyword which allows us to select the top n rows from any table. And from that particular table, we can use the top keyword to for any particular column. So this is how we can use a top keyword to get the n number of rows from a specific table. Now what if I want to use the select statement to create segment within the table? Now for this, when I say segment means I want to create groups within that particular data in a table. Now the scenario is I have this employee table over here, right? Now if I come to a new query and I write a simple query over here as select star from human resource dot employee, and if I execute this particular query, I can see over here that the employee table has a columns, and one column is there that is vacation hour. Now what I want to segment this particular vacation hour in terms of good, better, and not specified. So the output of this particular requirement should be, there should be three columns where there should be you can say the job title, the gender, the vacation hour, and one new column which will hold a value as good, where the vacation hour is between 20 and 50. There should be a term called better, where the vacation hour is more than 50, and for the rest of the vacation hours it should show me not specified. So there should be a new column at the end of this particular query. Now the question is how we can achieve this kind of queries over here. For this we'll use a case statement. Now what is a case statement? A case statement is a special kind of provision in SQL which allows you to define multiple conditions, and if any conditions gets fulfilled, then we'll get the desired output. Over here the requirement is that I want to create a new column which will show me good, better, and not specified for each of the condition defined in terms of the vacation hours. So what I can do, I can write select from human resource employee, and I want to select the column like gender, or I can start with job title, gender, vacation hour, and I'll use the word case where the vacation hour is, sorry, it should be, the case handles multiple condition as I said, right? So we'll write case when the vacation hours. So I can drag the vacation hour column from the employee table. I can just open this particular table quickly, and I can drag this vacation hour. So when the vacation hour is between 20 and 50, then mark it as good. So I created the first segment. And then when the vacation hour is greater than 50, then mark it as better, else mark it as not specified from the employee table. Now, one important thing that we need to keep in mind whenever you're working with a case statement, it's a piece of statement which should have a starting point and the ending point. Now, whenever we have defined a case statement, we have used a case keyword at the beginning, and now we have to end this particular statement over here with the end keyword. And now, what I have to do, now that I have segmented this vacation hour, I want to show this particular vacation hour in a new column. So I can define that particular new column with a as keyword, and I can name that particular column as segment, and I can put it in between the square bracket. And now if I execute it, so I'm getting some errors over here, let me check quickly. So there's a case else and as, okay, so I have to put a comma over here. Now, if I execute this select statement, you will find that I have extracted the job title column, the gender column, and the vacation hour column, and a new column as segment which states better for anything where the vacation hour is more than 50, and good where the vacation hour is between 20 to 50, and the rest has been marked as not specified. Now this is how we can use a select statement to create a segment within the table. And this is how we can create a new column by segmenting or by grouping the data in a specific column. Now we can have a select statement to group the data and creating a new column. So what I have done, I've defined three conditions, and those three conditions has been specified under the case statement. And those case statement, that particular case statement has an endpoint, and with the help of the segment column, I was able to successfully show these three conditions. One important implementation of select statement is you can also use select statement along with a time function. We can use the time components of our data along with the select statement, and we can show it as a different type of we can say values as an output. Now, to better understand this particular scenario, let's work on a requirement. Now in this particular employee table, I have a column called hire date. Now what I want to select the top 10 hire date from this particular table, and I want to show those values in terms of year, month and days in three different columns. Now how to do that? Let's see. So I'll write a query as select from human resource dot employee, and I'll select the top 10 hire date, and the requirement is that I want to show this hire date in three different columns as year, within bracket I'll write that column name as hire date. So I can bring the hire date over here, I can bring the hire date over here, and I can bring the hire date over here. I can close this bracket as I can name the column as year. I can show the second date as month, within bracket I can define the hire date column as month, and the third I can do is as day, and I can define the column name over here as day, and I can use a comma over here. Now what I have done, I have used the top keyword to extract the top 10 values from the hire date column, and as per the requirement I have divided this particular hire date into three different columns as year, month and day, Now where with the year function, year is an inbuilt time function of SQL which extracts the year from the given column. Month is an inbuilt function which extracts the month from a given date, and day extracts the day from the given date. And all the three functions have an integer return type. Now if I select this particular statement and if I execute it, I can see that the top 10 higher date has been extracted along with the year, month and day column consisting of the year, month and day from this particular date format. So this is how we can use a time component along with a select statement. How can I use the select statement to find the date difference? So for example, in this particular employee table, I have the birth date and the hire date. Now what I want to find the difference between the birth date and the hire date to find the age at which the person has joined the organization. So I'll use again a select statement for this, and I'll use select from the employee table. And what I will select, I can select the job title, I can select the gender, I can select the what I can go for. I can select the birth date and the joining date, or I can select the hire date from the employee table. And now we can use the date difference function to find the difference between the birth date and the hire date. So I can write over here date difference. So this is an inbuilt function of SQL which takes three arguments: the interval, which should be in terms of year, the start date, the end date, and I want to show it as joining age. And now if I execute this statement, you can see for each of the employee, the different job title, gender, and the hire date and birth date has been showcased in terms of join age. So this date difference function is also an inbuilt time function of SQL, which can be used to find the difference between the date. And over here, we are using it to find the difference between the birth date and the hire date of the employees. And we can find the join age of the employee from this particular table. So this is the way we can use the select statement on the various scenarios or use cases in our day-to-day work in SQL. I have discussed the different implementation of SQL statement in today's session, where I have used the operators, I have used the case statement, I have used segments from the table.
Now, joins are very important aspects of learning SQL. Why we require join in SQL? Now, join allows us to access multiple data which are resided into multiple tables in your SQL Server database. Now, over here, we'll be learning the most important aspects of joining, where we'll be working extensively on inner join, left join, right join, and full join. Now, the question is why we require join in SQL. There will be a lot of scenarios in your day-to-day work where you have to extract data from multiple tables. For example, if you have two tables like employee or department, and you need to understand that there is a data resided in department table and a data resided in the employee table. Now, for some reasons, while working with the employee table, there might be a requirement where you need to get some information in terms of the department from the department table. So in that case, we have to perform a join operation to get the data from the respective tables and to proceed with the options of working with different types of data. So let us understand the different types of join with an example. So I'll be talking about the inner join, the left join, the right join, and the outer join. So let me initialize my SQL Server Management Studio and let us see each of the joins with an example. So the best way to understand join is to understand it visually. So what I will do, before I discuss the inner join, let us understand what is inner join with a visual approach. So I have opened my the Paint application, and what I can do, I'll take two tables. So consider this is a table A and this is table B. Now if I want to perform an inner join, now there's a universal law that we follow while working with joins. In order to establish a join between two tables, there should be at least one column of similar data type available in both the table. The column name doesn't matter, but the column data type should be same. Now for example, in employee table, employee ID, and in department table, department ID should be of the same data type. But in case of establishing a join, in both the table, at least one column should be of the similar data type. Now, for example, if the employee ID column is available in the department table, then we can easily establish a join between the employee ID and the department ID. Now the question is, what is an inner join? In inner join, the join operation takes place on the basis of the matching criteria. Now when I say the matching criteria, I mean to say in both the table, at least one column should be similar in terms of the data type. In inner join, on the basis of this matching criteria, only those data will be extracted which matches with the matching criteria. Now let us understand this particular join with the help of an example. So as you can see in this particular picture, in inner join, only the matching data on the basis of that particular matching criteria will be extracted or will be selected from both the table. Now how we can achieve this kind of join through queries? So for that, let me go back to my SQL Server Management Studio and let me click on New Query. Now, for this particular example, I'll be working on the Adventure Work database. So let me initialize this particular database. Now, as we all know, this database is listed under the database folder. First, let me use this particular database. And now, let us select two tables on which we can apply the inner join. Now if I expand this particular database under the table folder, I can see all the tables listed under Adventure Work Database 2019. Now let me select two tables from here. First, let me go with the employee table. So let me write a query to see the data in the employee table. Select star from human resource dot employees. And now if I execute this particular query, this is the employee table. Again, let me write another query. Select star from. Let me take another table over here as the table which I am searching for over here can be. Okay, let's not work on this particular Adventure Work database. Let me work on the human resource database. So I'll select the human resource database from here, HR database. Let me remove these queries from here and let me use the human resource database. And if I execute this query, and now in the human resource database, if I expand this particular database and go to the table folder, I have this employee table and the gender table. Now let's understand, let's see what data we have in the employee table. So select star from table name, that is employee. Now if I execute this, I'll get the employee data. Let me select another table, that is gender table. So in this table, you can see in the employee table, we have the SID employees, employee number, birth date, first name, last name, gender, SID date, and the hire date. Now if I go to this gender table, select star from gender, and I execute this particular query, I can see that in the employee table and in the gender table, we have one column of similar type, that is the gender column. Now on the basis of this column, if I execute both the query over here, you can see the query is getting executed over here. If you can follow my cursor, you can see in the gender table we have the gender column, and in the employee table we have the gender column which are of similar data type. Now we can establish a connection between these two tables. Now what I want to select the employee number, the birth date, the first name, the last name, and the gender on the basis of these two columns by implementing a inner join. So let me write a query. I'll write select from, first let me perform the join from. Now what I will do, I'll mention the table over here. So I'll write the employee table and I'll create an alias of the table as emp. I'll perform an inner join by writing the inner join expression over here. And I'll mention the gender table over here and I'll take a alias for that particular table. And now on the basis of this alias, I'll be performing the inner join by referring the gender column. So I'll write gen or emp, or you can write gen dot gender equals to emp dot gender. And what I can do, I can write over here on. Now this on keyword allows initialize the joining operation. So what I have done, I have taken an alias as emp for employees gen as for gender, and on the basis of the gender column, I have performed an inner join. And now let me select the columns from the respective table. So I'll take employee number, I'll take the first name, I'll take the gender name from the gender table and the gender. Now you can see there is an error over here. What error? This is an ambiguous column name error. The SQL Server Management Studio is unable to identify from which table this gender column has been extracted or mentioned, because gender is available in both the table, right? So what I can do, I can write emp dot gender, and now you can see the error has been removed. So what I have done, I performed the inner join on the basis of the gender column, and now if I execute this particular statement, I'll able to see the employee number, first name, gender name along with the gender column from both the tables. So gender name has been extracted from the gender table and the gender column has been extracted from the employee table along with the first name and the employee number. So this inner join I have just executed with the help of a query where I have taken the gender column as a base. Now let's understand the concept of left join. Now for that, again, I'll go back to the Paint application. I'll just click on it and I'll just take this particular table data which I'm working on. So earlier we have seen that we have taken two tables and we have performed an inner join. Now for inner join, the matching data will only be published in terms of the matching criteria. But for left join, all the data from the left table along with the data which matches in terms of the matching criteria will be extracted. Now if you visualize the left join, it will look somehow like this, where all the data from the left table along with the data that matches with the right table on the basis of the matching criteria will be extracted. Now the question is how we can perform this in SQL with the help of queries. I'll go back over here in my SQL Server Management Studio. I'll take a new query for this left join, and the tables that I'm going to use for this particular example is an employee table and the managers table. Now if I select the data from the manager table and if I execute it, I can see in the manager table we have informations like position, from date, to date, SID employees, etc. And what I want to perform a left join on the employee table and the manager table. So what I can do, I can remove this star over here and I can select the table from here. So I can write the table name from employee table as EMP, performing the left join on the managers table as MGR on. Now the question is, what will be the matching criteria of the employee table and the manager table? Now in the manager table we have a SID employee column. Now if I right click on the employee table over here and I click on design, I can see in the employee table, there will be one more column called SID employee. So on the basis of this particular column, I can perform the join. So what I can do, I can write emp dot SID employee equals to mgr dot SID employee. And now the column that I want to select from the employee table will be, let me select the columns like first name, last name. So you can select employee number, first name, last name from the employee table, and from the manager table I can select position, and let's select the from date option, or so let's select the from date option. Now if I execute this particular query, I can see that from the employee table all the data has been selected on the basis of the matching criteria, that is SID employee, and where the data is not available, you can see there is a null value over here. Now what I can do, I can sort this particular query, or I can sort this particular column so that I can check whether is there any values in these two columns or not. So how can I do that? By using the order by clause. Now what I can do, I can perform a sorting operation on the position column. Now we can sort this particular column by also specifying the column position. Now over here the position column is located at the fourth from the left. So position column is the fourth column starting from the left, that is employee number column. So what I can do, I can specify the column position number and I can just sort it in descending order. And now if I execute this query, on the basis of this particular position column, the data will be sorted in descending order. And now we can see that after applying the left join, all the data from the left table and the data from the right table on the basis of the matching criteria has been populated and sorted in descending order. Now the key takeaways from this example is that we can sort a column by defining the position of the column, and over here this particular column position is located at the fourth position from the left. So this is how we can perform the inner and the left join. In my next video I'll be discussing the join in depths, where the other categories like right join and left join, right join and outer join will be discussed. Apart from this, I will also discuss about the advanced operations that we can perform by using join.
As I discussed in my last video, join is a very crucial part of SQL learning. In a day-to-day work with SQL Server, we have to work with various data which are resided in the various tables in the different parts of the database. To access those data, we use the concept of join, where the universal law of join states that to join two tables, there should be at least one column of similar data type available in both the table. Keeping that in mind, I have showed you how we can work with inner join and left join. In this session, I'm going to discuss about the other categories of join. To start with, let's start with right join. A right join is a type of join where all the table data from the right table is extracted and the data that matches the matching criteria from both the tables are extracted along with all the data from the right table. And data which doesn't match the matching criteria will always be showed up as null value in a table. To visualize this kind of join, let me take you to the Paint software, where I want to show you it visually as how right join works, and then we will work on the query part, where I'll perform a query to perform a right join between two tables. So we have seen over here that there are two tables over here. Now what happens in right join, all the data from the right table along with the data which matches in both the table as per the matching criteria gets extracted. So this is how we can visualize a right join. Now if I go back to my SQL Server Management Studio and I want to perform a right join, then I'll take a table where I'll be working with employee and the gender table. to perform this right join. Now, as I said, the employee and the gender table has a column which is similar in both the table. So if I write a query over here, select star from employee, and again, if I repeat this query, and this time I mention a gender table, and I copy and execute it, I select and execute it. So you can see there will be two output coming up. One will show the details of the employee table, and the other one will show the details of the gender table. Now in both the table we can see there's one column, gender column, which is similar, which is available in both the table. So over here we can see that on the basis of this gender column we can perform a join operations. So let's perform a right join, and as per the definition of right join, all the data from the right table and the data which matches the matching criteria from both the table will be extracted. So let me write a small query over here as select from employee table, employees table as EMP, performing a right join on gender table as GEN on Zen dot gender equals to EMP dot gender. Now over here, Zen and EMP are the alias name which is been given to the table like employees and gender. Now that I have performed the join operation, the output of this join operation will be extracting all the rows from the right table and the matching rows in terms of the matching criteria. Now what I can do, I can write the column names over here, gender, and you can see the moment I've written a column name, I'm getting an ambiguous error because the SQL Server Management Studio, this query editor, is unable to recognize this gender as from which table this gender belongs to. So we have to specify the table name, and we can do that by specifying the alias name that we have given to each of the table. And then again, I can write gender, gen dot gender name, and let me give the first name from the and last name and the EMP number. And now if I execute this particular query, I can see that I've got the gender column. Okay, let me take the gender name. And you can see I've got the gender name, first name, last name, and employee number. So as a result of this right join, all the data from the right table has been extracted and the data which matches the matching criteria. And over here, the matching criteria is gender. On the basis of the gender column, which is of similar data type in both the table, the data has been extracted. The next topic that I'm going to talk about is a full join. Now, what is a full join? A full join is a type of join where all the data from both the tables will be extracted on the basis of the matching criteria. So let us see how we can perform a full join. So let's first understand the full join visually. If I open my Paint application, we have seen the inner join where only the matching data will be extracted. We have seen the left join where all the data from the left table along with the matching data will be extracted. We have seen the right join where all the data from the right table along with the matching data will be extracted. Now we'll see the full join where all the data from the left table, the right table will be extracted along with the matching data. A word of caution, full join will always return a very big result. Another thing that I want to highlight over here is a full join is also known as full outer join in SQL. Now let us see how we can perform a full join in SQL Server. Now take a new query, and for this example, I'm going to work on the current personnel table and the geography table. Now this current personnel table under HR database consists of all the employees who are currently active in the organization. They are currently working in the organization. And the geography table contains the demographic details of all the people who are part of this particular organization. Now, if I write a query to understand what kind of data this tables contains, we can write select star from current personal table. And if I execute it, you will find the details of the SID employee, employee number, current salary, current location, along with the department ID, location ID, and position ID. And now if I check the geography table, and if I select it, you can see this particular geography table contains the location ID, city, state, provinces, postal code, country, region, name. Now what I want to perform a full outer join where I want to extract the data from the current personal table along with the geography table. And I want to perform it through full join. So I'll write select from, let me give the table name. So I'll write current personal table as CP, performing a full join on the geography table as geo on. Now let us understand the common column. So in both the table, we have an SID location column, which is of similar data type. We have seen in the current personal table and in the geography table that we have a similar column, that is SID location. So on the basis of that particular column, I'll perform the full join operation where I'll take geo dot SID location. And now let us select the columns. I'll write EMP number, comma. Let me take the, so what I can take over here from, let me take the city from the current personal table, and let me take the country region name from the geography table. And now if I execute this particular query, I can see that I have all the employee numbers and the city and the country from which that particular city is belong. Now what if I want to sort the employee number, and now if I execute this particular query, now the moment I have done a sorting, I can see some of the employee numbers are showing me a null value. That means the current personal table is having some employees who doesn't have an employee ID, and that is a matter of concern. Because if a person is currently working in an organization, the person should have an employee ID. So there's a problem with this particular data which needs to be updated to the HR, and they need to look in this particular matter, because a person who is working in an organization without an employee ID must be having some issue with the, either this particular table has not been updated, or there is an issue that is going on this particular organization which needs to be highlighted. So this is how we can work with the concept of full join in SQL Server. Now let's work on another scenario where I want to talk about implementing some advanced join features. For example, if I want to apply multiple joins on multiple tables, for example, I want to perform an inner join on three multiple tables. Now for this, let me take a new query, and I have three tables over here: the employee, the manager, and the salary history. Now this employee table can be considered as a master table which consists of all the employees who are currently in the organization and also who has already left the organization. The manager table can be considered as a table where the roles and responsibilities and the details for the managers in the organization are being stored. And the third table is the salary history table. Now, this particular table consists of all the salary history of the employees in an organization. Now, when I say salary history, every employee in any organization goes through a process where the salary is increased from the previous amount of salary that is given to the employee. So this particular table keeps a track on the salary history for each of the employees. Now, let us see how I can perform a join on these three tables. Now, till now, I was working on a join operation which was being performed between two tables. Now, let's see how we perform a join when there is more than two tables in the requirement. So for this, I write a very simple query where I write select from Now let's perform the join operation first. I'll take the employee table and I'll give an alias as emp. I'll perform an inner join on the manager table with alias name mgr on emp dot. I'll take SID employee as a common column in all the three tables because SID employee is a column which is available in all the three tables and are of similar data type. Equals to mgr dot SID employee from the manager table. Again, I'll perform an inner join, and this time I'll take the salary history table and I'll name it as SLR, and I'll perform an inner join on the employee table emp dot SID employee equals to SLR dot SID employee. And now it's time to select the columns. So in terms of columns from the employee table, I'll select the employee number, the first, last name. Now you can see over here, we can see an ambiguous. That means the employee number is available in more than two tables. So I'll write emp.employee. And from the manager table, I'll select the position and from date. And from the salary history table, I'll select salary history, salary from date, and sal to date. What I can do, you can see the current salary option, and let me denote it with the salary SLR. Now we can see that I have used three tables over here and I have performed an inner join on more than two tables. Now I have also selected the respective columns from all the three tables. Now it's time to execute this particular query and see what output we can get. Now in terms of the rules of the inner join, I have seen that I have extracted the first name, last name from the employee table, position and from date from the manager table, and current salary, salary from date, salary to date from the salary history table. Now this is how we can see that how we can perform a advanced level of join operations where we have involved tables, more than two tables in the query level execution. So this is how we can see that how we can perform our advanced level join operations. What if I want to perform multiple joins with multiple tables? Over here, the scenario was that I have performed a similar join type. So I perform an inner join in more than three tables. What if I want to perform multiple join types with multiple tables? Let us see how we can do that. Now the scenario over here is that I have three tables. First, the employee table, second, the employee location table, and the geography table. Now, there is a scenario, there is a situation in the organization where I want to verify that what information that is stored in the employee location. Now, this employee location table is the table which consists of all the information about the employees working in the organization. And this geography table is the master table, where it consists of all the details of the employees, which is there in the organization, or also which are people who have left the organization. Now there is a situation where I want to verify that the employee location table, the details supplied by the employees, is the information is matching with the geography table or not. So the scenario is that I want to verify that the location, which is the information that is available in terms of the postal code in employee location table, is that postal code correct by comparing it to the geographical code. And I will extract the employee number and the employee details from the employee table. So there will be three tables: the employee table, employee location table, and the geography table for this scenario, where I'll be applying multiple join type, the inner join and the left join, to verify the information stored in the location table with the information stored in the geography table. For this, I'll take a new query and I'll start writing the join operation. So I'll write select from And the first table is employee, which will be alias as EMP. And I'll perform a inner join with the employee location table, which I can name it as employee log. And I'll perform an inner join on the basis of SID employee equals to emp log dot SID employee, performing a left join on the geography table, which is aliased as geo, and I'll perform a left join with the geography table considering the table as. So what we have to do, we have to perform a left join as on the employee location table along with the geography table, because we are verifying the employee location table along with the geography table. Now if I open this geography table over here and if I check the columns of both the table, I can see in both the table the postal code column is of similar data type. So let's use this particular column for this particular join. So I'll write employee log dot postal code equals to, because I have to give a on operation or on keyword over here, equals to geo dot postal code. So what I have done, I have performed multiple join types by considering the employee location table, and the geography table. And in both the join type, I have taken a different criteria in terms of the column name. So we can see over here that the employee location and the geography table has been joined, and left join has been performed on the basis of the postal code. And now let's select the columns from the respective tables. Now the first column I will select is the employee number. I can select the first name, last name. I have to select the postal code and the postal code. Now the problem is that postal code column is available in both geography and the employee location table. So we have to use the alias name over here as employee log dot postal code and geo dot as postal code. And also I have to specify the emp name dot over here. Now what I want to show the postal code selected from the employee location table as local code, and the postal code selected from the geography table as global code. And now if I execute this particular query, you can see that I have got two columns over here where I can see that the information like employee number, first name, last name from the employee table, the local code from the employee location table, and the global code from the geography table. And now if I can see the local code and the global code are same in both the table, that means the information supplied by the employee is matching with the master table over here. Now you can see over here for this particular employee 2859, there is a null value in the global code column. That means the information supplied by the employee, that is the postal code 2444, is not matching with the master value. So there's a problem with this particular piece of employee, this particular employee who might have supplied either a wrong information or the master table was not been updated properly with the concerned postal code. So this is how we can use multiple join types with tables where we are working more than two tables. We have seen how we have applied the inner join and the left join within the same query, and we was able to work on a scenario where we were comparing the local code with the global code. The next scenario that I'm going to work is to perform a join within the same table. Yes, it sounds interesting, right? How we can perform a join within a same table. Now, performing a join within a same table, in SQL terms, we call it as a self-join. Let us work on a scenario to understand this particular type of join. I'll take a new query. And for this particular example, I'll be using the employee manager tree. So let us see what is this employee manager tree table contains. I'll select star from, let me name the schema over here, and let me take the table name. And if I execute this query, this particular table consists of interesting information. We can see there are three columns over here: the SID employee, the SID manager, and the full name. Now each employee has a manager, and each manager has an employee ID because the manager is also a part of the organization. So for employee 1, the manager ID is 1000 and the manager name is Georgie. Now what I want to know the names of all the employees along with the ID, and also the manager name along with their ID. So the output of this particular self join will be 4 rows consisting of the employee ID, employee name, manager ID, manager name. Now, how we can extract this kind of information from a same table. We can do this with the help of a self join. Now if you can see in this particular table, each employee has a manager and each manager has an employee ID. Now, if I come to this SID manager 1000, his name is CFO. If I want to know the manager of this particular ID, so I have to come down and I can see manager ID 1000, which is also an employee ID, doesn't have a SID manager ID because this particular person, Axel, is the CEO of the head of the company. So he doesn't have an ID over here. So he doesn't reports to anyone, right? So let us understand how we can get the employee name and the manager name from this particular table data using a self join. So let us write a query for this. So I'll write select from management dot employee manager tree, and let me give as alias name as emp1. I'll perform an inner join. Again, I'll mention the table name management dot employee manager tree dot emp2 on. I'll perform emp1 dot sid employee, because in this table the matching criteria will be sid employee and sid manager because these two column contains the similar data type, equals to emp2 dot sid manager. And now let's select the column names which I want to extract from this particular data or table. So what I can do, I can write emp1 dot sid employee, comma, emp1 dot full name, emp1, I'll write and I'll select the SID manager, and emp2 I'll select the full name of the manager. And now if I execute this particular query, I have got the SID employee and the full name of the employee, and the SID manager and the full name of the manager. So this is how we can perform our self join within the same table, and we can work on this kind of scenarios where we need to relate the IDs in terms of multiple position available in the table. Now this was all about joins and advanced joins that I want to discuss in this particular video. So the first thing that I'm going to talk about is views. So what are views in SQL? Views are some virtual tables which we create by using one or more tables. It's just like the same table that is available in the database. Now, for example, for this human resource database, we have a view over here
and we can see that this particular human resource database has tables like calendar, employees, employee position, and history. Now, what if I want to create a virtual table using the existing table which is available in the database, and that particular table will behave the same way that the other tables are there. We can perform all the SQL operations on that particular table, and we can also write the same queries to extract the data from those tables. Now, what are views? Views are just nothing but a virtual table which are created by using one or more tables. We can use the columns for one or more tables to create views. Now, if you come down over here under if you see this human resource database, there's a folder over here which is aligned as views. So this is the place where we create those virtual tables by using the existing table, and those existing tables are already available in the database of human resource. Now over here, we can either create a view from a single table, or we can create a view from a multiple tables also. Now when I talk about views, there are two approaches that I follow for view. First, we use the available options in the SQL Server Management Studio to create a table in views, or we create by writing queries. Now the question is why we want to use views in SQL. Now views sometimes allows you to create a table, a specific segment of the data. Now let me give you an example. Suppose if there is a let me give you an example of a coffee shop. Suppose we have a coffee shop. There's a coffee shop which is running. The owner of the coffee shop suddenly wants to know the trend of sales for a particular day. So what he can do, he can create a separate view, a virtual table, which will only contains the columns, the data for that particular day. And that particular owner can analyze those data for that specific day by creating a virtual table. Now, what are the advantages of virtual table? Obviously, if you create a separate virtual table for that particular day, then the queries will run faster because we'll not be considering the past records for the table. So it's a very fast experience while working with a SQL data or working with the SQL tables. Now the question is how we can create views. As I said, there are two approaches for creating views. First, we use the options available in the SQL Server Management Studio, and the second, we'll write a query for creating that. To create a view is very simple. Right click on the view, and there's an option over here, it's folder, and you get a new view option. And the moment you click on new view, you can see there are tables available over, and these tables are nothing but the tables which are already available in the database. These are the tables which you can see over here. So if you click on new view, you can see these are the tables which you can see over here. So I click on new view and I can see the tables over here. Now what I can do, I can select the tables from which I want to create a view. Suppose let me select the employee, add the employee table. Let me select the gender, and I can add the gender table. Now you can close this particular pop-up window. You can arrange the tables over here. Now this console is the console where you work with the view tables. So I'm creating a view using the employee and the gender table. I am showing you the first approach where I'm going to create the views using the available options in SQL Server Management Studio. Now that I have brought the two tables over here, let me arrange this table properly so that it can be properly viewed. Now let us see what kind of operations we can perform. In order to create a view, you can select the required columns from the tables, and you can see that I'm not writing a single query in SQL, but you can see the queries are already getting created the moment I'm selecting the column. And this particular part section, which is called a table pane you can say, is getting updated with the column name, the table name. And now if I select another column, you can see the query is getting generated automatically in the background. So I can select the first name, I can select the gender. So I have selected 4 columns, and the select statement has automatically created the queries over here, where I can see the table name from which it has been selected, and by default there is a join that has been taken place between the gender and the employee, which we need to establish. We have not yet established the join. As of now, I have selected the 4 tables. Now, once I select these 4 columns from the table, we can further add more information. Now, suppose I want to add a filter on the gender column. So I can come to this filter column and I can add a filter like male, you can see the where clause has been automatically updated, where the employee gender is equal to male, or also we can apply a logical filter also, where I can use a or condition to select the female gender also. Now you can see the where clause is automatically written. I am not writing a single line of query over here. I can also sort the columns. If I want to sort the SID employee column, I can come to this sort type column and I can select the option from the drop down. Now this sort order is the order in which the sorting is done. So this is number one. Now if I sort the employee number column, it will become under the second sort order 2. All the options that we can perform over here in terms of sorting is getting a number over here. So sort order is 1, sort order is 2. Now suppose, so you have written, you can see over here that for every step that I have performed in the table pane, query is getting automatically generated. If I click over here, right click on this particular option over here, I can see the left and right join are also available over here. If I select all the rows from the employee table, that means there will be a left join. You can see this is a left outer join that has been established. Now again, if I come over here and right click on this and I select all the rows from the gender table, then there will be a full join. If I again right click over here and if I remove the option right and full outer join, the default join will again come to inner join, which is done on the basis of the gender column. So we are using the available option, the point and click options from this particular pen, this particular view console, to create a table, which is a virtual table, which I'm creating from the existing table from my database. Now what if I want to execute this query? What if I want to verify this, whether I have performed a correct query or not, whether I have selected the correct values or not? For that, I have to come to this particular query pen. This is called a query pen over here. You have to come over here, you have to do a right click and you will find two options over here, execute and verify. If I click on verify the SQL syntax, I'll get a verification message over here showing the SQL syntax has been verified against the data source. Now if I want to execute it, I will again to right click on this particular query pen and I need to click on execute SQL query. And you can see in the execution pane over here at the last, all the rows of the table are getting executed in terms of the SID employee, the employee number, first name, gender, the 4 rows that I have selected. I can also stop retrieving the data process and we can have it. So we can see that we have executed this particular query over here and we can see the query has been successfully executed. That we have executed this particular query over here, it's time to save this query. We can also have an option to save this query. Now for saving this query, what you have to do, this particular part of the query which is written over here is actually creating the structure of the table. But this particular part, this order by part, is not a part of this particular query as we are using this particular command just to sort the data. So you have to remove this extra what you can say operations that we have performed in terms of sorting a column in order to save this query. Now this is a rule that we need to follow while saving a query which we have used for creating a view or a virtual table. So as this order by is not a part of the standard command which we have only used for sorting the data of the table, we have to remove this particular sort option before we save this. Because if we try to save the query along with this order by option, then the system will throw an error. And what kind of error? Let me show you that. If I select this particular query and click on save all, I can name this particular view as view table or first view. You can give it as first. And if I click OK, the system will throw an error because order by clause is only used to determine the row. This is a sorting function that I'm using over here. So that is not part of creating the data table structure. In that case, we have to remove this particular order by option over here. You can select and you can remove it. And now if I want to try to save it and I give it a name as first view. You can see I am able to save this view over here. And now if I refresh this view folder, I can see the first view. And now if I write a query over here like select start from first view, Okay, so we have created this view over here, which we saved last time. Now what happened, we can use this particular view as a normal table. For that, what I can do, I can click on new query. We need to make sure that we're using the human resource database over here. Now what if I write a simple statement over here like select star from first view that we have created. And now if I press execute this query, you can see this table is getting executed where I have selected 4 tables from the employee table, along with the where clause which we have used to extract the gender male or female. Now this is one approach of creating a view. Another approach is writing a query. Now we have the first approach that we have done, we have done right click, selected the new view option. What if I want to create a view by writing a query? I'll click on new query and I'll write as a simple query as create view. Let me name this as second view. Now I have created the view name. Now for the content of this particular view, I can copy this particular piece of code. Now this particular piece of code is nothing new to you. Yesterday when I was discussing the self join, if you remember, I have written this particular query where I use the employee manager tree table with 2 different alias name, and I have extracted the manager name and the employee name along with the ID. So I'm using that particular same query for creating a new view which name is SView. Now this time I'm writing a query to create a view. And now if I select this particular query and I execute it, you can see the command has been successfully executed. And now if I refresh the view folder over here, you can see the new view that I've created using the query. And now I can again write a simple query, or let me write this particular query over here only. Select star, the view name will be, and now if I execute it, you can see I can get the same data which has been extracted as a result of this particular self join that I have created. So I have used that particular query as a, what you can say, to define the structure of the new view that I created. And this time the new table that I've created under the view folder, the virtual table that is created is SView, where I have used the columns from a single table, that is employee manager tree. So these are the 2 approaches by which we can create views in SQL, which are a set of virtual tables which we create either from a single table or by using multiple tables. The next example is an interesting example where I'll be using the into clause to create a new table by selecting the existing columns from the available tables in the database. Now for example, let me describe a scenario for this. Now if I open this table folder, there are a lot of tables over here like departments, employee location, employee movement history, employee position history. Now what if I want to select some columns from the employee and the gender table, I perform certain join, I perform certain filter, done certain kind of sortings, and all these operations that I have performed using the employee and the gender table, with these operations, I want to save the output of this particular query as a new table in my database. I repeat, the requirement is that I want to perform certain operations on the table of employee and gender, and I want to save the output of that particular operation as a new table in my database, and the database over here is human resource. So how can I do this kind of operations where I can save the output as a new table in my data? Let us see that. I'll take a new query for this, and what I can do, first let me perform the operation that I want to do. So I want to select the employee number, the birth date, the name of the employees, the hire date, and the gender name from the respective tables like employee and gender. I am more focused on getting the details of the male employees, or it can be a female employee specifically. And I also wanted to sort the birth date column, which will be a part of the data extraction process from these 2 tables using a inner join. So first let me write the query, and then I will create a table out of this particular query. So I write select from, I write the table name over here as employee, and I will also include one more table with the help of inner join, that is gender, which I will name as gen, and I will perform a inner join on the basis of the gender column which is available in both the columns. I will write emp.gender equal to gen dot, and I'm specific about I want to only get the data where the gender is, or it can be female, and also I want to perform a sort operation on the birth date column of the employee table. Now that I have performed the join operation and I have defined the filter also with the where clause, I have defined the condition of the by the where clause, and also I have performed the sort operation. It's time to define the columns which I want to select. So I want to go for the employee column, employee number column, the birth date. Also let me go for the name of the employee. Let me go select the hire date also, and the gender name from both the tables. So I've selected the column. I have defined the join operation on the basis of the matching criteria using the gender column in both the tables. I've also applied the filters in terms of a specific condition, and also I've sorted. Now if I execute this query, I'll get the required columns from both the table. I've got the female condition over here from the gender table, and I've also got all the employee numbers, and also I have sorted the birth date column over here. Now whatever this is a very simple join operation that I performed, which I have already discussed earlier. The purpose of this example is to show you what if I want to create a new table that will contain this particular output. For that, what do you have to do? I want to use a keyword over here, or a function you can say, or a command you can say, which is into, which will create the new table. And let me name the new table as emp female in my database, or we can say emp female birthdays to be more precise. So what will this into command do? It will create a new table in your database which will contain this particular output. Now if I select this particular command, this query, and if I execute it, you can see 12,000 or 1,20,000 rows has been affected. Now if I go to this table folder, and if I do a right click and refresh it, you will be able to find a new table over here with the name of emp female birthdays, which we have just created by using this into command. What it has done? It has done nothing. First, it has selected all the columns in terms of the conditions and the filters, and then with this help of this particular command, it has created a new table in my data. And now, if I use the select star from command emp female birthday, and if I execute this command, you can see I've got the same set of information which you have got by using this command query. So yesterday I remember someone was asking me whether we can save it as a part of a table or a new table. So this is how we can do that. Now the next example is going to be a very complicated and a very big example where I'm going to discuss using the insert option, some advanced level implementation of the insert command that we have in SQL. Now insert, as you all know, is a very common command. I can easily show you that insert into table name values and that sort, but that will not serve the purpose over here. Whenever we are discussing an insert, there should be a proper scenario where we will use the insert option to update a record in a table in such a way that we do in our day-to-day work, or where we interact with the SQL Server. Now for this example, I want to discuss about a scenario where an employee who has left the company after working for a couple of years and again came back after a few years, or again came back after wanted to join back the company. And there can be various reasons for that. An employee, they can come back to the company. There can be various obvious reasons for that. Now, how will the HR people, or the database person will manage this kind of queries? Because the employee was already a part of the system. The particular employee left that particular system, and after a specific interval, He came back, the employee came back and the employee wanted to again work in this particular organization. Now the question is, after a lot of discussion, it has been decided that that particular employee ID will be again be activated into the database, and this is a very common practice in many organizations where the employee leave and again they try to come back after some time. So what happens? The employee ID becomes deactivated, and again when the employee comes back, the ID of the employee needs to be activated. Now the conditions can be many. There are many conditions in terms of activating an employee ID. The conditions may be whether the employee wants to join with a new salary slab or the employee have accepted the last salary slab. There are various conditions that can be applied. Now over here, this particular employee has left the organization and has come back and has decided to join the organization on the same employee ID and with the last withdrawal salary that the company has offered the employee. Now when the HR head decided to onboard this particular employee, there are few constraints, there are few challenges that came while onboarding this. The first is that we need to check whether this particular employee ID was there in our system or not. Now, in this particular human resource database, there are two sets of information in terms of employee. First set of information is the employee table, and the second set of information is the current employee, current personal table. Now, this employee table is a master table where all the employee, whether it's a current or whether it's an ex-employee, data is available. But this particular current personal table only consists of those data of employees who are currently active in the organization. Now what we can do? This particular employee number is what I am going to work is 100. We have to check the presence of this particular ID in two tables before we proceed to bring back this employee to the system. The first thing that we have to check is whether this particular ID is available in the employee table or not. Now, if I write this particular query, this is a very simple query where I am searching a particular ID in the table, the master employee table. Now, if I execute it, I can see this particular employee was a part of the organization. But the moment I check it to the current personal table, I can see there is no such ID. That means this employee was there in the system, but presently not active. Now, the requirement is that as I have hired the employee back, I have to update the current personal table with this particular ID, which is not there at present. Now, this is the scenario. Now, it's not an easy thing because if you go and check the current personal table now, select, or what you can do, you can select a part of this particular query. When I execute it, this current personal table contains information in terms of SID employees, employee number, current salary, current location, department, SID location, and SID position. Now this looks quite simple, right? But no, these columns are actually also available in the master tables for each of the employee. For example, this particular ID is also available in the employee table. This particular 100 ID should also be available in the employee location table. This particular ID should also available in the employee movement. This particular ID should also be available in the employee position history table and also into the salary of the salary table, salary history table. So all these columns are related to the salary history, geography, employee. So I need to check all the tables over here whether this particular ID is available or not. So I have to verify all the tables which are related to the current personal table. Like for example, current salary column is also available in the salary history table. So I have to check the salary history table also for this ID, whether this particular ID is available or not. I have to check the employee position table. So there's the employee position table over here. I have to also check the employee movement table. So there's a employee movement history table, because when this particular employee was there in the system, all the tables were containing this particular ID. So I have to check whether this ID is also available on the other tables or not. And then after getting a confirmation, I have to start working on updating the current personal table with this particular ID. So let's start writing a query for that. Now what I will do, I'll come to the next line and I will start selecting all the tables where these columns are available. So first thing what I will write, I'll write select employees as, let me give it an alias name as T1. and I will select all the values from that particular table employees where the EMP number, you can see there's the EMP column over here, right? EMP number 10021. Close this execution. So I have searched for the employee number. Now second, I will search the employee number in the employee location table. So I'll copy this query and I'll write a second query. I'll write employee select EMP location and I'll name this alias as T2 from employee location table. Where EMP number should be present, whether this employee number is available or not. So I'm checking for this employee ID for all the related tables. I'm now checking the location table, the current location, this particular column. The next table that I'm going to search is the employee movement table. I'll name it as EMP movement as T3 from the employee movement history table. I need to check whether this employee number 10021 is available or not. I'll again copy this. The next table that I'm going to search will be the employee position. As T4, I'll give it an alias name as T4. And this employee position information in terms of this particular employee is available in the employee position history table. I'll delete this particular table over here and I will write employee position history table. And the last is I want to search the salary of this particular employee in terms of the ID from the salary history table. Over here, whenever we are searching a salary, we need to keep in mind as an HR that a salary of an employee also includes a salary history of the employee also includes the appraisal that the employee has received during the tenure in the company. Whenever you're working with the salary part, you have to always consider the last 5 salary slab that the employee was offered. Now, how to do this kind of query? Simple. You copy this particular query. And to search this particular employee in terms of salary, I will write the employee salary, EMP salary option over here as T5 from the current or the salary history table where the employee number in is 10021 and the salary should be sorted in descending order for the last 5 withdrawal. So we have used a sorting option where we will take the last 5 salary slab of the employee in descending order. Now if I execute this query, you can see all the tables where this particular employee ID is there has been extracted. So this employee ID is also available in the employee table T1. This employee ID is also available in the T2 table. So in T3 table means employee movement table is also the employee ID is available 10021. The employee ID is also available in the employee position history and this is the last 5 withdrawal salary where the last withdrawal salary was 84,169. Now on the basis of this salary, it was decided that we need to bring back the employee into the system. Now one confirmation what we got from this particular query that this particular employee was an active employee where the details of the employees are all available in the respected table which captures each and every movement of the employee in terms of the location, the movement history, the position, the salary history, and in terms of salary history, we have also got the last 5 salaries of the table with the highest salary. The last withdrawal salary for the employee was 84,169. Now, on the basis of this particular salary amount, the next step is to update the current personnel table where the employee ID is not there. Now, what do you have to do? The next step is that now that I have got all the columns over here, where I can see that these columns are all available with the required data, we'll select this particular column from the respective table. Now we all know whenever we are selecting columns from the respective tables where there are multiple tables involved, we perform a join. So all the columns like employee number, SID locations, all the columns that we have searched till now, we select those columns from the respective table where the employee ID will be 10021. The first we have find the column, second we will be selecting the column. For that, I'll again take a new query and let's start writing one more query. Now these queries, you can see how big these queries are. These are multiple lines of queries where we're performing join. This is what we do in our day-to-day work in Office. And then we extract the data and we prepare the reports. So this is a requirement that I'm working where I have to update a table with the missing data. So I have to search all the tables in the database. So I've got the details of the employee. Okay, fine, this employee was there in all the tables. So I don't have to update this table separately. Now that I have got the details, let's select this particular column. Why am I selecting this particular column? Because these particular columns are all available in the current personnel table. So you have to select all the columns from the respective tables where the employee ID is available. So I'll take a new query and I will start writing another query where we'll be selecting the columns over here. So I'll write select from, I'll first use the employee table. I'll perform an inner join. Now this all is inner join will be done with a common criteria. And what is that criteria? The criteria will be SID employee. For all the tables that I've selected, you can see SID employee is available in all the tables, right? So this will be the common column on the basis of which we are going to establish the connection or the join operation. So now let us write the query. Let me write the query. From employee as EMP, we perform an inner join on the employee location table EL on EMP dot SID employee equals to EL dot SID employee. The next table that will be part of the join is employee movement history, which will be given a name as EMH, and it will perform a join on the employee table emp.sid employee equals to emh.sid employee. And again, we'll join this table with the help of an inner join with the employee position history table, which we can give a name as EPH on, and we perform the join operation again with the employee table. So we write emp.sid employee equals to EPH.sid employee. So you can see in all the tables the SID employee column is common and the same data type. And the last table that we're going to use is the salary history table, which will be marked as SH as an alias and will be joined with the employee table on the basis of the SID column equals to SH dot SID employee. Now that we have selected all the columns, now that we have used all the table for joining purpose, it's time to define the condition. What will be the condition? Where the employee number will be 10021. And the columns which are going to select from all these tables on which we have performed join are, now we'll mention those columns. The first column will be selected from the employee table, and that is SID employee. The second column that we are going to select is the employee number. The third column that we are going to select is the salary. The fourth column will be the city. The fifth column will be the department. These all columns are part of the current employee salary, the current personal table. So we'll select the department column from the employee movement history, that is SID department. The next column will be SID location, which is in the employee location history table. You can see how big these queries are getting slowly. The next column will be the position from the EPH, employee position history. And now I will execute this query, the moment of truth. Let's see how we can do, whether we will define the things properly or not. And if I execute this query, so I have got an output over here. Now this output has a mistake. Now what is the mistake over here? We were able to successfully pull out all the required columns for the current personnel table, but this particular columns is showing us multiple salary over here. But our focus was, the condition was that the employee will be taken back on the basis of the last withdrawal salary, that is 84,169. But over here, when you're selecting the column, I'm getting all the 4 salaries over here. Now how to fix this kind of error? Now this is not an error, but this is the execution is giving us a wrong output, not a specific output, because our concern was to select all the columns from the respective tables on the basis of this particular salary, right? We cannot include all the other salaries over here. To fix this particular issue, we'll use the concept of subquery. Now, as we have performed a join operation over here with the current salary history table, it is actually fetching all the data related to those salary under this employee. But we have to only focus on this particular part of the employee. So we will write a subquery where we will say maximum salary among all these 4 salary slab that we have got as an output. Now how to fix this? We'll write a subquery in this particular query that we have written. Now what is a subquery? Subquery, as the name specifies, that query within a query. Writing a query within a query. So we have already written a query, right? Now we'll write another query within this particular query. And that particular query will take care of this maximum salary. For that, what you have to do, in place of this particular column, this current salary, we'll write a simple query over here, which will be selecting the maximum salary from the current salary column, which is available in the salary history table, where the employee ID is so simple, right? You can see where the employee ID is, or the employee number is equal to the employee number which is available in the employee table. And I want to show that particular column as current salary only. That's it. What I have done, in order to select the maximum salary from this particular column, I have written a query within the query. And now that I have specified the maximum salary over here, what I can do, I can remove this particular join over from here. And now if I execute it, this query, now I can see I have got the maximum salary from all the tables that I have selected, and for current salary I have written a simple subquery within the query which will select the maximum salary from the current salary column using the current salary history table, where the employee ID should be equal to the employee ID which is available in the employee table, and that particular column will be shown as current history column. Now let's go back and let's see, because this particular employee table is a part of our whole query execution, which actually contains the data in terms of the employee number, the master table. That's why I'm referring that particular table over here. Now these are some things which you will come to know slowly and gradually over the practice the best ways to write a query, where instead of giving the direct numbers, we can refer the master table, because the master table, it is assumed that it contains all the correct data. So that's why I'm doing. This is one of the practice that I follow. So I always keep the master table as a reference. And over here, the master table is the employee table. And the employee number is already available in that table, which we have already checked. That's why I'm referring that table over there. Now that we have selected all the columns over here, the next thing that we have to do is the most important part. Let me go back and let me show you the things we have done. First, the requirement was that this particular employee ID should be brought back to the system. Now what we did, first we checked this particular ID in the master table, it was available. Then we checked in the current personal table where it was not available. So we checked all the corresponding table from where these columns were there. We can see the output, and we can see that yes, this ID was active in the corresponding tables also, which contains the other information of the employee in terms of the location, the movement, the salary, and all. Now once we have confirmed about this particular ID of other tables, what we did, we selected all the columns from those respective table using the join operation. You can see all the columns has been selected, and also we fixed the salary issue, which are showing us the last salary slabs also, but we were only focusing on the highest salary, because on the basis of that condition only the employee was decided to brought back to the system. Now that I have selected all the required column, now it's time to insert this detail into the current personal table. Now for that, what we have to do, we'll write a very simple statement over here. We'll write insert into, and what is the table name? Current personal. And what will be the columns over here? I'll write SID employee. I'll write the employee number. I will write the current salary. Current salary. I'll write the current location. Department ID. The location ID. And the position, and I'll close it. So I have insert all the values in the respective columns of the current personal table where this ID was not there. And now against this particular ID in the current personal table, all these details will be inserted that has been extracted from the other tables using the join operation. Now if I execute this particular query, you can see one row has been inserted. Now to check the effect of this particular row, we'll write select, or else I can go back to this particular query. If I execute it, you can see current personal table is now showing me that particular ID employee number, which has been brought back to the system. But still, we can see that the SID location is showing us a null value, another error in the output, or you can say another gap in the output. But before I focus on solving this null issue, let's get back and see what we have done. So we have found out that one employee is coming back. That employee was there. We checked with the details of the employee. We selected all the information from the required table, and then we have inserted it into the current personal table. And what is the takeaway from this example? The takeaway is that for inserting a simple value in a employee, what are the things that you should take care of? And this is a very common real scenario that we face in a day-to-day work. Now, I'm not talking in terms of a data analysis, but the people who are into HR domain and all, who are actually actively maintaining this kind of systems in their organization, have to go through these steps, because they cannot just, now entering a new employee into the system is a very easy thing. You just create an ID and you can just update the required tables. But what if an employee comes back to the system on a specific condition? Over here, the condition is that, okay, fine, I will work on my last withdrawal salary and I want to keep my old ID only. Now, this depends on the HR compliance of the year. We'll follow these steps. But still, when I run this particular step, I was able to insert this system. I was able to make that particular employee again active in my system, where the current personal table is showing that yes, now this ID is active. But still, I don't have the location details of the table. The ID, location ID for that particular employee. This is one more issue that we need to solve now. Now, how to solve this kind of issue? Now, over here we can see that the SID location is showing us a null value. Now, how to get this particular ID for this location? How we can track this ID? Now, you can see for every location ID, I have the location name with me. You can see the location name over here, right, in the current location. So, what I have to do, I have to find the ID against this particular location, and where this location is located is updated. This location is updated in the geography table. Now, if I search the geography table, select star from geography, table geography, where the city is equals to the name I have to give. What is the name? And if I execute this query, okay, I've got the SID location over here. So for Dunkerque, the SID location is 116. So I have to update this null value with 116. Now let's start the process of updating this null value. Now how to update this particular null value? For this, I have got the reference, right? Okay, fine. This particular ID is 116, which is available in the geography table. Now we have to first get all the details in one place. How to do that? So for this, we'll be using the current personnel table and the geography table. So we'll write a query over here, right? Select star from, or you can just copy it, right? Star from current personnel table as CP, and you can perform a join operation with the geography table on the basis of the matching criteria. Now let me check the matching criteria. Now I have this city over here in the geography table, right? And in the current personnel table, I have the current location. So these two columns, the current location column from the current personnel table and the city column from the geography table are of similar data type. So we'll use these two columns. So we'll use as on, I will take the city column from the geography table, and from the current personnel table, I will take the current location. And let me add a condition over there, where you can take the SID employee. Let me check if it goes to the SID employee, where the SID employee is equal to 21. Now if I execute this query, I've got all the columns from both the tables. Now what I have to do, let me study this. Now what I have to do, I have to update this null SID location column by selecting the value from the SID location column from the geography table. So I have got all the columns from both the tables. Now from the current personnel table, this SID location column should be updated with this particular value 116. So what we can do, we can simply use an update statement, right? So that update statement, what we will do, update the current personnel table where the column ID, where you have to set the column ID SID location with the value of the column from the geography table, that is SID location. Now let me define the table from current personnel table, that is CP, equal inner join with the geography table as geo on the basis of the city column and on the basis of the current location column from the current personnel table. So over here we have used the current location, right? Yes. So current location, where the SID employee is equals to 21. Now if I execute this query, so I was able to insert a row over here, and now if I come back over here, I execute this select statement, fine. So you can see that SID location this time has been updated with 116. Earlier it was a null value. So what we did, we simply updated the current personal table where the SID location column should be equal to the SID location column from the geography table, where we have performed a join operation on the basis of the city and the current location, and we have defined a condition where we have taken the SID employee as 21. You can also take the employee number also, no problem. Now you can see how we have updated this particular table. Now I have a full-fledged information in terms of the employee who had come back to the organization with a specific condition. Now this is the whole process that we do in terms of using an insert command. This is the best example that we can have for working with an insert command. Now insert I could have showed you by simply creating a table and inserting a value, but that will not serve the purpose, right? We need to have you to understand things in a way that is used in a day-to-day work. So this is one of the scenarios that is very common in the HR practices, where we maintain certain ERP or certain database in terms of the employee. Now the next example, again it's a very interesting example. Now what happened for this particular example, I want to take a table. So for example, if I select the take one more table for this. So select star from this time let me take the employee movement history. Now there is one more scenario that we work on day-to-day work is if how to concatenate two columns from a table. This is also one of the important scenarios. Sometimes there are requirements where we have to work on concatenating two columns. You can simply update it 116, but yes, it's always you should refer the geography table over here because that is the master table which contains all the required information. For this employee movement history table, what we have done, I need an output where I want to concatenate the SID employee and the SID department table. Now I want an output with a new column which contains the concatenation of SID employee and SID department. Basically, I'm showing an example how to concatenate two columns, to add two columns, to combine two columns. For this, what I have to do, I have to do a simple change in the table design. What I can do, I can click on this design, I go over here, and I can just change a design where I can add a column. Now this is one way by which you can add a column. I have also shown you how we can add a column in our previous discussion. So let me add a column as test and let me set the data type as int over here. And what we can do, just refresh it and we can just check whether we are able to add the column or not. Yes, so we are able to add the column over here. Now that I have added a new column, what I want this particular new column to contain the concatenation of the employee ID and the department, which is at present showing null. So how to do this kind of operations is very simple. We'll use a command called cast. Now cast, what is done? It's a kind of a command which actually transforms the concatenation function in your table, which actually combines the concatenate operations in your table. Now how? Let us see with the help of a simple query. Now what I want, I'll again use an update statement for this. So I'll use the update the table name. The table name over here is employee movement table history. And I will set the test column over here equals to I'll use a command called cast, and again I'll use a cast within it where I will use the SID employee column along with the varchar over here. Add this particular column with, again, using this cast function with the SID department column, where I have to mention the data type, and I'll update it as int value because I've defined it as an int. Now let me check if I'm able to capitalize this particular value or not. So we have affected 3 lakhs rows over here. Now if I select this employee history table again, okay, fine. So we have got a 4 new column. The test column has been updated as a result of concatenation of the employee ID and the department table with the help of this particular cast built-in function, which actually used for type conversion. So the type conversion in terms of data type was the employee table, which is in a varchar, and the department table also was having a varchar, so it converted this data type into an int, and we have concatenated these two column with a plus sign. Now this is a very simple example. However, this kind of scenarios will be very easy for you to handle, where you have to combine two columns. Now you can easily use the plus sign to concatenate, but over here we are using this particular cast function over here as an inbuilt function just to convert this varchar from both the table into int. Fine. So we will be working on the human resource database for understanding the concepts like constraints, aggregations, and stored procedures, variables. For that, let me first initialize the human resource database. So I'll take a new query and I'll write a simple statement over here, use human resource. So it's already been in use, I guess it's showing over here. But if it doesn't show over here, you can just use the human resource and you can execute it. And now let's start on the first constant is a primary key. Now what is a primary key? Now you have been familiar with this particular term in my previous discussions also. The primary key is a column in a table which cannot have a null value, which cannot have a duplicate value. All the values in that particular column should be unique in nature. Now the question is, can a table have more than one primary key column? Yes, it depends upon the use cases. If you're working on specific use cases where we need to have two primary key column, yes, you can have. But a primary key column should always contain a unique value and it cannot accept null values. So a primary key is a kind of a column in any table. Now, for example, I have given in my previous discussions, I have talked about that there should be at least one column which should contains a unique value, and that can be considered as a primary key column or a primary key for that particular table. Now the question is how we can create a primary key column in SQL Server Management Studio. Now there are two approaches that we follow. First is we can create it through the data definition language, where we can use the select or you can use the update function. And the another way is to use the design of a table to mark a particular column as a primary key. Now let us understand the approach where we can use the design of a table to mark it as a primary key in SQL Server. For this, I'll come to this human resource database and I'll click on this particular table folder. Over here, we are working on these tables over here, states the details of the employees, the departments, and etc. So if I open this employee table and if I right click on this particular table, I can select the design option. Now you can see over here the SID employee is marked as a primary key. Now what if I do a right click over here and you can see there's a lot of options over here. Among this, we can see the option called remove primary key. If you remove this column is no longer a primary. Now what if I want to make another column as a primary key over here? Now, for example, this employee number. Now let's first understand what is the difference between the SID employee and employee number column over here before we allocate one of the columns as a primary key.
The SID employee column is a column which consists the ID of the employee which has been allocated by the system, a system generated icon, ID. But an employee number is the employee ID, which can be also be a system generated, but it has certain criteria in terms of employee number. But an SID employee will be any random ID which is created by the system for any referential, you can say, value for future references or any other internal log reference for which this SID column has been created by the system. Now, what if instead of using this SID employee column, I want to use this employee number? The employee number means if I go to a new query, let's first see what are the values we have in the employee number and the SID number. I'll write select start from employees and I'll execute it. So we can see there is some serial number that has been an indexed column has been allocated in terms of SID employee, and a number which starts from 1001, 1002 has been allocated to the employee number. Now what I want to consider this particular column as a primary key for the table employee. Now, how I can allocate this particular column as a primary key? We can use the right click option from mouse and take this particular column or field header. I can do a right click over here and I can select this option over here as set primary key. Now you can see the moment I select it, there is a key icon that has been created over here. And now if I save this, the save option over here, and now if I come to this employee table and I right click on this particular table and I refresh it and I open this column, you can see this employee number column, there is a key icon which is prefixed in the column name, which signifies that this particular column, this employee number column, is a primary key which data type is int in nature, which cannot accept any null values, and all the values in this particular column are unique in nature. Very important terms in terms of work with primary. Now this is one approach of a primary key. Another approach which I generally don't use because these approaches are mainly used for the database admin summary is a DDL approach, that is data definition language. That is by writing a query where we can allocate a column in a table as a primary key. How to do that? So this is one option I have shown you where you can use the point and click options which is available in the SQL Server Management Studio, where you can right click and you can set a column as a primary key. The another way is to write a query for example, we can write a query as create table name. We can write a query over here, create table. You can write a table name over here. For example, I'm just showing you a sample how this approach works. I can write a table coffee, and I can name the column name over here as coffee ID over here, and I can set this, or you can name this particular column as CID. You can set the data type as integer, and I can write as not null and a primary key. And I can close this. So you can write this kind of queries also when we create a table where we can define the table name and we can just define the column name where we have to define that this column should not be null and this can be a primary key. So there are two approaches, one is through queries and another one is by using an existing point and click option where you can define a primary key. Now the question is, when we know it is a primary key, then another constant that comes into the picture, that is a foreign key. So what is a foreign key? Now for example, if you remember in my previous sessions I have discussed that a primary key of table A can be a foreign key of table B. Now again the same things comes that a foreign is there any possibility that a table can have multiple foreign keys? Again, yes, it can depend on the use cases or the business case scenarios where you are handling. A table can have multiple foreign keys. Now, in order to understand the concept of foreign key and how we create a foreign key in SQL Server Management Studio, let us understand with an example of two tables. Now what I will do, I'll take two tables over here. The first table is an employee table. Second table is a employee location table that we have in this particular database. Now what I want, remove this particular primary key over here and let me assign an SID employee as a primary key, and I'll let me save it. Now a foreign key is basically used for a referential identity, means we can refer a table to a foreign key. We can connect our table to a foreign key where we can use that particular foreign key as a reference, connect with that particular table. But the question is how to create a foreign key in a SQL Server Management Studio. So what I have done, I have taken two tables, the employee table and the employee location table over here, where in the employee table, I have actually made the SID employee as a primary key. If I refresh this particular table over here, you can see now SID employee is the primary key over here. Now what I want, in the employee location table, you can see the SID employee column is available over here. I want to use this particular column. I want to refer this particular column as a foreign key. Now how to do that? Now in this employee location table, if you come down, there is a folder over here called keys. If I right click on this particular folder, this keys folder, you can see there's an option coming up over here as columns. If you right click over here, you can see there's an option coming up, a new foreign key. Now if I open this particular key folder, there is no such keys available as of now. So what we will do is create a foreign key with the help of this particular folder. So I'll do a right click over here, click on new foreign key, and there will be an option coming up where we have to exactly set a procedure to use the SID employee as a foreign key in the employee location table, which is a primary key in the employee table. And you can see over here, now you can see like general identity and table designer. Under general option, you can see there are option called table and column specification. This is the option through which we'll create the foreign key. Now if I select this particular option over here, you can see there's three dots over here. Now if I click on these three dots, over here we'll have two sections. The first is a primary key table and the second is a foreign key table. Now if you think logically guys, the primary key table over here will be the employee table because that is the table where the SID employee is a primary key, right? So what I will do, I'll select the employee table from here. And if I come down to the action area, I have to select the column name. Now we can see the primary key table, I have defined it as an employee table and the column name is SID employee. Now let me come to the foreign key table. The foreign key table over here should be employee location. And the column in this employee location table, which I want to convert or use as a foreign key is SID employee. So I have defined a specification in terms of creating a foreign key within the employee location table with the help of the primary key table, that is an employee table. And now if I click OK, I click add and I click close, employees, I guess I used some steps, SID employee. And now if I refresh this key folder and if I open this, if I save this, you can see this SID employee has a key icon which is quite different from the primary key which is available in the employee table. And these two foreign keys, actually I've created twice the foreign key, I can delete one. So you can see this foreign key, the number of foreign key this particular table has been listed over here. So this table has one foreign key which has been created, and this is the icon of the foreign key. You can see the color of this icon is quite different than what we have in terms of the primary key. So
you can identify that this SID employee in the employee table, in the employee location table, is a primary key, is a foreign key, which is a primary key in the employee table. So let me create this foreign key. Let me create one for the so I deleted it, and if I refresh this table now, you can see the foreign key has been removed. So let me create the foreign key once more. I'll do a right click on the key folder, click on new foreign key. I can come over here, select it, this option, and I have to define the primary and the foreign key table. The primary table will be the employee table, and the column will be employee ID or SID ID, SID employee. And for the employee location table, I'll use the SID employee column, and I click it, and I click close. Now refresh the employee table. To save it, if an table over, you can see the SID has been marked as a foreign key, and this particular foreign key is also available under keys column. So these are repeated values which are created because I'm using the same option again and again. So you can choose to have a one option, and you can remove one, and you can change the name of this particular instance of the foreign key that is available under key folder. Now you can see the difference between a primary key from the employee foreign key from the employee location table. So this is some of the constants that we can create. This is some of the rules or limitations you can see we can create in terms of the foreign key and the primary key. The next constant that we can discuss is about a default constant. A default, as the name implies, that we can set any column as a default in any table. Now, how to set a default? For example, if you have a table over here, for example, let me take the manager table. If I right click on this particular manager table and I click on design, so I can see this particular manager table has four columns: the SID employees, the position, the from date, and you can say the to date. Now what I want that any particular column, I want any one of the column in this particular manager table to contain a default value. Now that particular value can be any value. It can be a default value, can be a blank also. So if I specify that particular column, okay, it should not contain any value. The value should not be specific. Then we can use that particular column as a default value as a not specific. Now how to do that? How to set a column's value to default? For example, now suppose if I come to this position column. In this position column, if I come down to this column properties over here, if I expand this particular property over here, you can see there is an option over here called for this column is default value or binding. Now if I specify this option as not specified, you can see the moment I press enter, this particular not specified column is delimited, means it has been covered under the single quotes. So what I have done, the default value for this particular column called position, I have made it at not specified. So whenever we will try to insert a value in this particular table, this particular column will be showing us as not specified. Now what if I want any particular value which I insert in this particular column in terms of date, that date should show me the present system date. Now how to do that? Now for example, if I select this from date column, for every column I have a column property where I can see this default value and binding option. This is the option through which we make a column value default. So we have just made the position column default value as not specified, and then I have selected the next column as from date column where I'll use the get date option to get the present system date over here. Now if I save this, If I save this and I refresh this particular table and if I select a new query, and now for example, if I write a small query over here, now what kind of query I can write? Let me select first all the data from the manager table. Select star from manager. And if I execute it, I'll get all the values. Now for some reason, what I want the this particular SID employee 100617 to be updated in terms of the to date. Now what will happen? Let me insert a new value. I'll write insert into managers. Let me define the column name as SID employee. Let me define the column name as to date. And the value which I want to update over here is, let me see what values can I insert. For the SID employee, I can find SID employee first. 100617. And for to date, let me insert a value like what date I should insert. Let's insert 2001. Let me close this, and now if I execute this particular value, I can see one row has been affected. And now if I select star from managers and let me sort it by 1, and if I execute it, you can see the second column where we have set a default value in terms of the position as not specified, and where I have set a default value for from date to get the present system date from my system. You can see the present system date over here, that is 2021 0206, which is today's date, and the to date value is 2001 which you have tried to insert over here to the insert statement. So what does the default constant does? Whatever column you set as default and whatever value you can set, whatever function you set for inbuilt function, like for example I have used for the date column, it will capture the present system date and it will mark the position column as not specified. Now this is a kind of a constant after primary key, foreign key, default, which we can apply to the table as a constant for any table data. So this is one of the constant. The next constant is also very simple constant, that is not null. Now not null you can see over here. If I come to any system table design over here, you can see this is also a type of constant where we can make a column null accepting a null value or not accepting a null value. So not null is also a type of constant which we can make it at the design level in the SQL Server Management Studio, which also sets a limit for any particular column whether it should accept a null value or whether it should not accept a null value. Now you know the use cases in terms of primary key or the foreign key where you can set a column and you can make that particular not to accept a null value in terms of primary key. Fine. So the next topic that I'm going to talk about is again a very interesting topic, and that is aggregations. Now what are aggregations? I have discussed aggregations in Tableau and in Power BI also, where we use multiple values to get a single value. Now we can use the function. We have used functions like count and count distinct kind of functions and aggregation average functions. The same way we'll use those aggregate functions in a SQL Server. So that is called SQL aggregations. The different types of functions that we have, aggregate functions that we going to work today is count, count distinct, sum, average, mean, max, having clause. Having is also kind of an aggregation. It's a very interesting aggregate function that we have in SQL, and you can say having is a very interesting clause in terms of aggregations that we have in SQL. So let's start with the first aggregate function, that is called count. So again, I'll go for a hands-on example for all these examples. I'll take a new query. So we'll take the first aggregate functions as count. Now let us work on a use case for this. Now what I have a requirement where I'll be using the employee location table to count the employees in terms of the various cities with respect to a particular country. I repeat, I want to count the employees with respect to cities for the various cities with respect to a particular country. Now, how to write this kind of aggregate functions? Now, count is a very simple function. You know how what count does, but how we can implement a count in SQL, that is the area of focus. Over here, we have a table called employee location. You can see this employee location table over here. Select start from employee location, Control E. So you can see this employee location has columns like employee number, city, state, region name, country, region name, and postal code. Now the requirement is that I want to count the number of employees in terms of SID employee for each of the cities with respect to any particular country over here. So how to write this kind of queries using a count function? So you can write select city, comma, SID employee. Okay, just let me first define the table. That will be easy for me. Select from employee location. So I've used the employee location table. From this employee location table, I will use the city column, comma. I'll use the SID employee. Now, what I want to count the employee on the basis of this particular column. Before I implement the aggregate function, so I have selected the city and the SID employee from the employee location table, and I want to count the employees with respect to the country. Let's name it as Australia, where the country region name is equal to Australia. And now what I want, I have selected the required columns, but I want to count the SID employees, the employee ID, the employees for each of the city from this particular country. So I'll use a count function for this particular column, and I want to show this particular column as employee count. And I want to group the city column from this particular table. Now let's see what happens if I execute this query. So you can see the approach that I have followed. First, I have defined the columns as per the requirement. I have defined the table name, and also I have defined the condition. The condition should be the country should be Australia. So now if I execute it, you can see the query is getting executed. Now I have got all the employee count for each of the cities for the country Australia. You can see Brisbane, you can see some of the familiar cities of Australia like Sydney, Hobart, Rhodes. So you can see the employee count for each of the city in terms of the country Australia. Now if I remove this group by clause from here, now if I execute this particular query without the group by, it will throw an error because we cannot use a column name with an aggregate functions without a group by clause. So you can see the city name, column name is used with an aggregate function. So whenever you're using an aggregate function and if you're using a column with that, so you need to use a group by clause to group that particular column. And now if I select this particular query and I execute it, you can see that I have got the options over here. So this is how we can use a count function, a count aggregate function with a specific condition and multiple columns. Now what if I want to count the employee number from a specific column? Now let's take a new query for this. Now this is a very interesting example. You will see a very good difference. Now I want to show you the difference between count and count distinct in SQL. Till now we have count function which have also taken the null values into consideration, duplicate values, everything. It has been counted. Now what if I want to know the specific values in a column? For that, let me take a new table for this. What I will do, I will use let me select the salary history table. What I will do, select from salary history. Let me see what the salary table first contains. So I'll write a star over here and I'll execute it. So this salary table contains the SID employee, employee number, current salary, the salary from date and to date. Now what I want to count all the distinct employee from this particular column. First, if I use simple count function, if I simply use the count aggregate function, count employee number, you can see EMP count. Let me take it again. And now if I execute it, you can see over here that I have got a number as 9 lakh employees over here. So 9,01,617 employees are there in this particular column. What if I apply a distinct function with this? Just keep an eye on this number. So this particular count function has taken all the rows into consideration, but the moment I apply a distinct with employee number, you can keep an eye over here. It's 9,01,617 numbers, right? So if I execute now this particular query with a distinct function, this number has reduced to 2,58,986. That means this particular column was containing multiple occurrence or duplicate values of employee number. Now, that can be an obvious reason because this is a salary history table. It will capture all the histories of the employee in terms of the salary hike or the number of salaries that has been paid to the employee. So you can find the difference between a count which has been applied with multiple columns to specific conditions and how this count and distinct count actually affects the result of a table. Similar function we can use a sum function. Now with this particular sum function you will try to understand a new example as arithmetic overflow. The problem of arithmetic overflow in SQL. A very common problem that we have in a that we face in a day-to-day work with SQL Server. Now, what is an arithmetic overflow? For that, just let me show you something. Just allow me to take the control for a second and let me open something and show you what is an arithmetic overflow. Now, if you remember, in the first initial classes of SQL, I was discussing the concept of data type, right? Now, where I have defined the range for each of the data type. So, each data type that is big int has a particular capacity of values that it can hold. For example, int has a specific range of data that it can hold. In case of small int, tiny int, decimal, it has a specific range of data that particular data type supports. Now, what if this particular range exceeds for any of the data type? Then the SQL Server will throw an error as arithmetic overflow, means that the value of data, the value this particular data type is containing is more than what it has been made for. And if you understand logically from the word itself means arithmetic overflow means the range of value for this particular specific data type is more than what it is meant for. So let's understand this particular error with an example. So I'll go back to my SQL Server and I'll take a new query. And through this example, I'll show you another aggregate function that is called sum. For this particular example, I'll use a table called, let me take a table called current personnel. There's a table over here called current personnel. What I will do, I'll write a simple query where select star from current personnel. And if I execute this query, you can see the tables like SID, employee, employee number. These are the columns that we have. Now what I want to apply a sum aggregate on the current salary column from this particular table. So I'll write a simple query as select from current personnel table where I want to apply a sum function on the current salary column. And now this current salary column may contain some decimal value also. So what I can do, I can use the decimal option over here, and let me define the range of this particular decimal. Decimal less proportional. Okay, salary. Yeah. Let me understand this error first. Sum is not a recognize built-in function. That means it's an int function. Sum has will always return in int, and if I use the decimal over here. Okay. Let me convert the decimal into int. And now, if I close this, I execute it. Okay. So you can see this conversion of decimal into, because sum is an inbuilt functions which returns an int kind of data. Now if I use a cast, it has what it has done. This current salary column which contains can contain a salary into decimal point. It has allowed this particular conversion of decimal into int. Now if I can execute it, you can see that I have got a value of this particular sum from the current salary table. Now whenever you are using this kind of options, you might have a chance to get an arithmetic overflow error over here. Now, as I explained you, this is a common error that we face in this particular stage while working with these aggregation functions. So we can understand this arithmetic overflow functions at this particular. This is a very common stage where you use a sum function to calculate this kind of aggregate values, and then there is a possibility that the system can throw you an arithmetic overflow error. So in that case, you have to be very careful in terms of defining the data types. Now this cast function is what it does is converting this decimal into an int data type, because sum may return a int value which is int in nature. So this cast function plays a very crucial role over here while working with the sum value. Similarly, like sum, we have an average. So we can use the same column as an average to calculate the average for the salary over here. So you can take a new query and I can just paste this particular column. I can just simply change it, the sum, into an average. And what I can do, I can name a column name as average pay. So now if I execute this, you can see that this is an average pay that I have got from this current salary column. Similarly, we have one more very interesting, you can say, aggregate function is called mean and max. So mean max, as the name implies, is used for handling the minimum and the maximum value. For example, if I want to select the minimum salary and the maximum salary from the salary history table in terms of the employee number, how we can do that? For example, I can write a simple query: select from employee history table or salary history table So I've selected the salary history table, and now if I select the column like EMP number from there, and I want to know the minimum salary from the salary history table, so I'll write mean, I'll define the column name, and let me name that particular column as minimum salary. I'll take another function called max on the column name current salary, and I'll name that as a maximum salary. Now if I want to use a sort a group by clause over here, which I want to apply in terms of the employee number. And now if I execute it, I have got the employee number column and the minimum salary for that particular employee number and the maximum salary for that particular employee. So I have got both the information from the salary history table by using the current salary column, where I have got for each employee I have got the minimum and the maximum salary. Now what if I want to find a movement in terms of the salary? Means how much is the difference between the minimum and the maximum salary. Now every employee goes through a cycle where his salary is increased or that particular salary is appraised. That can be a very shocking thing for an employee if the salary get decreases. I'm sure that this kind of thing doesn't happen anywhere. But yes, the movement in terms of the salary is very important part of an analysis whether we do. So how we can calculate the movement for each of the employee, how much increase has been done. And what I can do, I'll write one more query. I will write minimum current salary minus max current salary. And let me name that particular column as now if I execute this particular query, I've got another column salary movement. But over here, you can see that each of the movement value over here is showing a negative value. So you can remove this particular negative value by using one more built-in function that is called absolute function. So for applying absolute function, you have to type ABS, and I can put this particular two values within this absolute function. And now if I execute it, you can see all the negative values has been removed, and you can see the actual salary movement. So for each of the employee, the actual hike in terms of the salary movement has been captured in the fourth column, and we have removed the negative by using the absolute function over here. So this is how we can use the min-max aggregations in SQL. The next is a concept called having. Having is not a function. It's a clause that we use in SQL. Now, why we use having clause in SQL? Now, what happens? We use a where clause when we define an aggregation, where we define a condition. Sorry. So you all aware of the where clause that we use in a SQL query, right? Which actually takes care of any conditions like where the country is equals to Australia, where the employee ID is equals to such an ID. Now, what happens? Where a clause has a limitation. What limitation? The limitation is that we cannot use an aggregate conditions over there. For example, let me show you a new query over here. So I'll take a new query. Now, what if I want to select the employee number? So I want to select from the salary history table. From this table, I want to select the employee number, and I want to use a where clause where the current salary is greater than 6 lakhs. I close it, and if I execute this particular, so you can see there is no error over here, right? What I have done, I define a condition, which I always do for the where clause. But this condition has an aggregate function. Now, if I execute this particular query under where function, the system will throw an error. And what is an error? An aggregate may not appear in the where clause unless it is a subquery in a having clause. So we have to use a having clause to handle this kind of conditions where we are using aggregate functions within that condition. And now, if I replace this where with having, a having clause should always be aggregated with a condition where we can use a aggregate function. And whenever you are using an aggregate function within a having clause, we have to use one more clause along with having that is called group by. And what I want to group by over here, the employee number. And now if I execute this particular query, you can see that I have got all the employees whose salary is more than 60,000. Okay, let me increase the value to 6 lakh. You can see these are the employees whose salary is greater than 6 lakhs. Over here also I am using a condition which can be easily used in the where clause, but the only limitation that this particular condition have is that we have an aggregate function. So this is how we can use the having clause. Now always you should remember, it's a very important interview question in terms of where and having. Where to use a where and where to use having. Both are handling conditions, but where cannot handle a condition where there is an aggregate function. For that we use having, but having clause should always be used with a group by clause. Few things, takeaways, that you should always use a group by whenever you are using an aggregate function within the columns also, as I showed in a previous example. Second, you should always know that you cannot use an aggregate functions with a where clause, so we have our option called having for that. The next topic, we'll talk about SQL programmability. So where you will be talking about variables and store procedure. Very interesting topic again. Now what are variables? A variable is an object that holds a value of a specific type. You can say it can be user-defined variable, it can be a system-defined variable. Now I'll talk about both the types of variable and how we can use variable in SQL. So variable is a kind of object that holds a value. That value can be float, integer, date. So that's why the definition states that a variable is an object which holds a value of a specific type. Over here type means data type. Now there are two types of variables that we deal in SQL. The first is user defined and the second is system defined. Now let us understand both the types of variable. So for this particular discussions we'll be using this particular folder over here, that is SQL programmability. I'll take a new query over here and let me first write a user defined variable. So you know what is a variable? It holds a value, right? Now in SQL we have two kinds of variables, system defined and user defined. A user defined, as the name implies, the user can create a variable and that user can use that particular variable to store a value. Now how to define a user defined variable? We use the word declare for that. Declare. Let me define a variable name as, so I will use the @ symbol to define a variable. So let me define a variable is my name. So I've defined a variable and the definition says it's an object that holds a value of a specific type. That means I have to define a type also. So this particular variable will hold a data type of varchar. And the limit of this particular varchar, so you know what is the difference between char and varchar. So it's a dynamic, you can say, data type. So let me define the limit as 80 over here. Now that I have defined the variable, I have also defined the type of the variable. It's time to insert a value to this particular variable. So let me define the name as Amit over here. Now one important thing that I want to highlight over here, whenever you declare a variable always works within a batch. Now what is a batch? Batch is this particular statement. So whenever you're executing a variable, it should be executed within a batch. So I have defined the first statement of the batch as the variable name, the type of the variable and the value of the variable. Now it's time to execute this batch. How to execute this batch? I'll come to the next line. I'll simply write print variable name. And now if I execute it, you can see my name over here. But if I simply execute this particular part, you cannot see the result over here. So always you have to execute the variable within the batch. So this too is a part of a batch. So if I execute it now, you can see my name over here. Now the next variable is how we can use a number. So let me take one more example. To declare, again is the declare function @ my phone number. As now this time I will define my phone number as int, and this time I will not assign a value to this variable through a equal to operator. What I will do, I will take one more way to insert the value as I will take a set option and I will define the variable name, and now I will assign a value as my phone number as, and I will close it. And now if I want to show this particular number, I use a select statement, and I can also call that particular variable. And now if I execute this particular batch, you can see the number over here. So these are all user defined variables that I'm talking about. Now what if I want to use the system defined variable? These are all variables which is created by me. Now what if we want to use a system defined? Now system defined are inbuilt variables that SQL have. You can see these are local variables. User defined variables are, you can say, local variables which life cycle is within that particular batch. You cannot use this particular variable with another instance of a database. No. Now how we can use some of the inbuilt variables? For example, if I want to know the version of my SQL server, I can write select @ you can have to give 2 times @ and you can see the system defined variables over here. Now if I want to know the version of my SQL server, I can write @ version, and also I can use the inbuilt variable to know my server name also. And now if I execute it, you can see the version of my SQL and the server name is star, which I'm using. Now what if I want to use some system defined variable along with the tables that I have in my database? How we can use the system defined variable along with the database? For example, if I select star from, let me take an employee table, and now if I use select @ I want to count the number of rows of this particular table, and now if I select this to batch and execute it, you can see that I have got 2 outputs. The first is the table, the employee table data, and the second the number of rows from this table. So there are total 3,24 rows. Let me check. You can see 3,24 rows. So you can use the system defined variables along with the tables that we have. So this is how we can use the 2 types of variables that we have. The first is the user defined, which I have used for showing the name, we have used for showing the phone number, and the second is the system defined. Now why I discussed about these variables? Because variable plays a very important role in stored procedure. Now what is a stored procedure? A stored procedure is a set of statement. Now what is a statement? This is a statement. It's a set of statement that is grouped in logical unit and is stored inside your database. Try to understand the definition. It's a very simple English definition. A stored procedure is a group of statement. What is a statement? These are all statement. It's a group of statement which is organized in a logical unit and is stored within the database. Or you can say a procedure is a function that is written in SQL with the help of certain variables, with the help of certain data definition language, that is select statement or update statement. So a procedure contains a variable as an argument. It can contain a select statement. It can contain an update statement, insert, but it should be organized in a logical unit which can be stored within the database. That's why it is called stored procedure. Now the question is how we can write a stored procedure in SQL. First, what is the benefit of writing a stored procedure? Now stored procedure is a very what you can say, it improves the performance of your query. First, it can be referred, it can be used again and again for solving any, for working with any specific business or use cases. It makes your query more and more fast, and it's very easy to maintain a stored procedure in a SQL server. Now these are all the terms that I'm using which are used by a database administrator. So that is the purpose that the DBA always creates a stored procedure. So before we write a stored procedure today, it was very important for you to understand all the aggregate functions, because we use a lot of aggregations, we use a lot of constants, we use variables, system defined variables, we use a lot of user defined variables within a stored procedure. Now let us see how we can write a stored procedure in SQL. Now I'll take a very simple use case that it will be easy for you to understand. Now for example, we have to define a scenario. Now I'll be using employee location table. Now if you remember, I have used a count function where I was counting the number of employees from the employee location table. Now there are two ways, or not two ways, you can say there are two rules for working with store procedure. First, you have to define the store procedure. Second, you have to call the store procedure. Means you have to execute the store procedure. I repeat, there are two steps that we follow while working with store procedure. First, we have to define the store procedure, what that particular store procedure should do, and then we have to execute that store procedure. Now let us understand the end-to-end, how we can define and how we can execute a store procedure in SQL Server. For that, I'll take a new query. And what I can do, let's first define the store procedure. To define a store procedure, what we'll write? We'll write create procedure, and we'll name this particular procedure as you can see. Let me name it as EC, for example. And I'll pass an argument to I'll define a variable in this particular procedure. So I've defined a procedure name, create procedure EC, and a variable which will hold a value as a part of this particular procedure. Now why I'm defining this variable, it will clear for you. So I'm defining a variable, for example, at country. As I said, it will always start with at symbol. The data type of the variable, let me keep it as varchar, and let me define the limit as 50. So what I have done, I have declared the procedure, and also I have defined the parameter or the argument that particular procedure should take. And now it's time to define the body of the procedure. I'll come to the next line, I'll use the word as. And now I'll write data definition language to define the function of this particular store procedure. So what is the function over here? I'll write a very simple function. Select from the employee location table where I want the country region name So we have the country region name column in the employee location table, where I want the country region name is equal to what I can do. I can define it as the variable name. Let me take the variable name over here. So country region name should be the variable name that we have defined over here. And now what column I should select from here? I select the employer, the city, and I want to count the SID employee in terms of the city as employee count. And now let me group by the employee, group the city, group by, and also I want to sort the employee count in descending order. Let me add one more clause. So I want to sort the employee count column, EMP count column in descending order. My store procedure is complete. So what I have done, I first defined the store procedure. Then I have defined a variable as a parameter or argument for that particular store procedure, and also I have defined the function that particular store procedure has to be performed. So this particular store procedure, what it will do, it will count the employees the way that we have done in the count function earlier. So we have used that particular function only within this particular store procedure. So as per the rule, we have defined the store procedure. Now it's time to execute it. How to execute a store procedure? We'll come to the next line. I'll use the word exact the procedure name, that is EC, and now I'll use that particular variable country over here. So exact EC @country, where I want to assign the country Australia per se over here. And now if I execute it, you can see the command has been successfully executed. And now where I can see this particular store procedure, if I refresh this programmability folder, you can see the name of this particular store procedure that I have created. It has been stored under this programmability folder under the system stored procedure, where I have created this EC procedure over here. Now what if, now suppose over here what I have done, I have used a variable which is I have already declared within this store procedure. Now what if I want to use another variable which is not a part of this store procedure? I want to select one more country with the help of a variable which is not a part of this particular store procedure. So till by now you know how to declare a variable, right? So let us declare a variable, another variable which is not a part of the store procedure. So write declare. I write another variable as country. I'll define the data type as varchar. I'll close it. And now if I define a country called France. So what I have done, I have defined a new variable which is not a part of this particular procedure called EC. So I have defined a new variable. I have defined a data type of the variable, and this time I've selected the country France, which is in the country region name column. Now if I want to execute this particular variable as a part of this procedure, what I will do, I'll go to the next line. I'll use the execute function. I'll use the procedure name. I'll use the variable that I have defined with that particular procedure, that is country. Equals to, I'll use the new variable name @count underscore in. And now if I execute it, you can see the results over here. So all the countries from France and all the countries in terms of the employee count has been highlighted over here. So this is how we can use a variable outside the procedure to execute that particular procedure over here. And this procedure will always save under the programmability folder under your SQL Server, under this particular database that we have. So you can see this procedure name, and this is how we can declare another a variable outside the scope of the particular procedure, and you can use that particular variable to execute that particular procedure. Now, this is how we define a store procedure, and this is how we execute a store procedure. The body of the store procedure can be any data definition language using aggregate functions, var, clause, or select statement. But to execute a store procedure, you have to always follow this particular step, where you have to use an execute function, the exact function over here, to execute that store procedure. So this is how we define the store procedure in SQL. This is how we work with variables. Now the concept of schema and indexes are very important in terms of working with day-to-day queries in SQL Server. I'll also talk about how we can use some techniques to optimize the query performance in SQL Server. So let's understand these topics with some simple examples. Fine. So what is a schema? Now if you can see over here that for this particular database for human resource, you can see there are a lot of tables which are listed under the table folder. Now over here we can see that for each of the tables there is a prefix written as DBO. Now what is this DBO? DBO is a schema under which this table is created. Now the question is, what is a schema? Now we all know that database consists of tables, views, stored procedures, field, record, functions. Now all these objects of a database follows a particular structure through which we can implement the security features, through which we can implement the authentications level to the end users. Now these implementations of authentications or security is done to the schema. If you talk about the definition, a schema is a structure through which you can see it is a structure by which all the tables, views and stored procedures are defined in a database. Now the question is how we can create this kind of schema. Now DBO means database owner. This is the default schema that we get while creating a table in a database. Now you can see there are schema like management, there are schema like payroll. Now if you want to see the schemas where the schemas are listed, you need to come down in the security folder. In the security folder, you can see that we have folders like users, we have folders like roles, we have folders like schemas, and under this schema you can find this DBO schema, you can find this management schema, you can find this payroll schema listed. Now the question is how we can create this kind of schema and how we can create a table under a schema. So the next example, I'll show you how we can create a schema like DBO, management, payroll, and how we can create a table under that particular schema. The way we are seeing it over here as DBO.departments, management.employee manager tree, payroll.employee payroll. Now to create a schema, we follow an approach of data definition language and the data control language. Now, if you remember, in my initial discussion, I talked about the 4 important commands, right? The data manipulation language, data definition language, data control language, where we use the different types of approach to work with the table structure, the table data, or the data query language. So we'll use such commands to create a schema, and we'll also create a table under that particular schema. Now how to create a schema? For example, I'll take a new query and I'll write a simple statement over here, create schema, and let me name that particular schema as secure audit, and I'll use the word authorization. Now this is the steps that we follow to create a schema. DBO, that's it. And under this particular schema, I'll define a table called create table EMP audit, or I can use uppercase for this for the table name, EMP audit. And as I've defined a table, I need to also define a column along with the data type and the acceptance of the null values. So let me define the column as SID employee. The data type will be int, and let me not allow any null over here. Now that I have created a table, let me define how we can use the data control language to to define the security level that I want to provide for each of the users who access this particular schema. Now to define the users, what I have to do, I have to first create 2 users and then I have to assign the security roles for them. Now the question is how we can create users and then assign the roles. Now what if I execute this particular schema? So you can see this command has been successfully executed. Now if I come over here and if I refresh this schema, you can see there is a secure audit schema has been created. And if I go up over here and if I refresh my tables or database, and if I expand my table, you can see the security audit.emp audit table has been created over here. So under the schema secure audit, we are able to create a table, and in that table we have a column called SID employee with the integer type as int, and that will not accept any null value. Now what if I want to assign some users for this particular schema with a specific roles in terms of authentication. How we can assign a users for this. So for assigning a user of this particular schema, I need to first create a user. So I'll just come down to the security folder again, and under the users folder I have to create two users. I'll right click on new user, and I'll use the user type as SQL user without login, so he doesn't have to provide any credentials. And I'll create a user as, let me create it as staff audit, and I'll give the default schema over here as, let me give it as DBO only. And I click OK. So you can see first user is created. Let me create another user. Right click, new user. The login type, make it without login, and let me make it this user as business user. And I click OK. Now I created two users over here. Now what I want to grant few roles to them, some authorization to them. The first user that I create, I want to grant that user that particular user can select from that particular schema. So I can come over here to this particular new query option, and I can write grant select on schema, and the schema name is secure audit, secure underscore audit, and the user will be to, let me take the first user, staff audit. The second authorization that I want to give is, I want to deny the select action. I want to deny the select action for the second user. So if the second user cannot perform the select option on this particular schema, so I will write deny select on the schema secure audit to the business user. Now if I execute it, and now if I come down over here and if I refresh this particular database once more, now if I come to the security folder, and if I come to the schema over here, and if I click on the secure audit schema and go to properties, and if I click on this permission option, you can see these two users has been added to the schema. And for each of the user, you can see the permission that has been granted. So over here you can see for this particular schema, the select permission has been denied. And for the staff audit user, the select permission has been granted. So we have added two users for this schema with a different permission level, where one can select the data from this particular schema and the second one cannot select the data. You cannot manipulate the data, or you cannot query the data from this particular schema. Now this was a fair idea about the schema, how it creates and what roles we can play over the schema. Now what we can do, we can understand some of the functions that we can write in SQL. So we will work on some functions. We'll work on some loop functions, how we can use a loop to create a table and to retrieve a data into the table. And also we can see how we can use some functions like some length functions or some trim functions like left or right functions. We can also see how we can find the index of a character. We'll also see how we can use a replace function in SQL. So the first function that I'm going to show you is how to find the length of a particular column. So let me take an example for that. I'll take a new query, and as I'm using the human resource database, select, I'll use a length. So what is the length function does? It calculates the length of a particular column that is supplied as a part of that particular, as an argument or as a parameter for that particular function. So I'll select from employees And what I want to select, let me select the employee number, and let me select the last name. And what I want to do, I want to use a length function on the last name column, and I want to show that particular column as length of name. Now if I execute this particular option, you can see the length of each of the name in the last name column. Now if I want to select star from employees, you can remember the first two length 7 and 6, right? So if I select, so the first length, the length of the last name of the first row is 1 2 3 4 5 6 7. Okay, and the second one was 6. 1 2 3 4 5 6. So we are getting a correct value in terms of calculating the length of the last name column, where we have choose a different column name to show the length. I think I'm getting a question over here. Guys, this database is already uploaded in the drive. The human resource database and all, everything is uploaded. Pinak, you have to go and check your dashboard. The link is already uploaded for the sample data set for SQL. It's long back. It's before the SQL session only. I guess I have updated all the sample data set. You can just download it from there and you can use it. The next function that I'm going to use is a left function. Now you all know we have used left function in Tableau also. We have used a left function in Power BI also. Let's see how a left function works in a SQL. I'll take a new query and I'll write a simple query where I'll be using again the employee table. So I'll write select from employee table, and what I will select, I'll select the employee number, I'll select the first name, let me select the last name also. And what if I use a left function on the first name, and I want to project it as an initial. Now let me execute this particular, I'm going to give a comma over here. Now what if I ever execute it? So you can see that I've got the first name. So what has left function done? It has extracted the first letter G, B for the second name, and it has created a new column with the first initials. Now what if I want to create a column using the initials for the first name and the last name? Something like this. What if I go for an option like this? I'll get a new line and I write a function again using a left function on the first name, but I will extract the first character. I'll use a operator over here to concatenate these two particular value of first name and last name. So what I can do, I can take a dot and I'll again use a plus sign to join the last name, and I want to use it as a short name. Use a comma over here, and now if I execute it, I can see that this left function has extracted the first letter from the first name and it has actually joined the last name to get a short name for each of the employee in terms of the employee number, name, first name, last name, initial, and the short name. So this is how we can use some of the functions within a query. Some string function you can say within a query. Now what if I want to use a function like character index to find the index position of a character in a column? Now for that, let me take a new example. I'll take a new query and this time I'll use the current location table. So select star from current location or employee location on this. Now what I want to find the character index in terms of the I guess let me select the current personal because I'm looking for a specific column over here. Current personal. So over here in the current personal, I have a column called current location. Now I want to use the char index function to find the position of n in a current location column. So let me see how we can use this particular function. So I write current select star from. Let me use this particular option. So I can use select star from current personal where you can use a function called char index. It's a built-in functions to search or return a particular position of a character in a int value. So I'll use this particular function char index and I'll search a character position n dot in a column called current location. And I'll use a operator over here which is more than 0. Now if I execute this particular query, it has returned me the position of n for the current location column. So we are able to see that for the North Vancouver, for the current location column, it has returned that particular value with this char index. Now what if you want to replace this n with North? I don't want to see this n. I want to replace this n with a word called North Vancouver. So for that, I can use another function called replace. Now what I can do, I can modify this particular query as select emp number current location, and in the current location I want to replace the n dot with North. And I want to show it as a new location, as a new column, so as a new or updated name from the current personal table where this char index function will execute. Now if I execute this particular option, you can see that I have got a new column with the updated name as North Vancouver for each of the current location where it is n dot Vancouver. Similarly, in case of, so we can see that how we can use some of the inbuilt functions in SQL to find some of the information from an existing table that we have in the database. What if we want to apply a loop function in SQL? Now people who are not from programming background, they might be wondering what is a loop. So loop is a type of an option, or you can say it's a type of a procedure that we define in any, say loop is basically used for in programming languages, but you can also use loop to perform a task repeatedly. Now if you want to type a number from 1 to 10, for example, now each time you cannot write a number individually, right? 1, 2, you cannot input a number individually into a database by using an insert function, by insert 1 in column 1 or like this. You cannot insert a number. What if you want to perform this task repeatedly? So you have to take the help of a loop function. So what does loop do? You start the loop and it will run till this particular condition is fulfilled. Now if you tell the loop, okay fine, you have to run 10 times, and every time you run you have to print the numbers with the increment of 1. So the first time the loop runs, it will print 1. The second time the loop runs, it will print 2. Now the question is how to create a loop and how to tell that particular loop that okay fine, you have to print 1 to 10 for me. You have to run or execute 10 times, and every time you run you have to print a digit for me, for example. Now what are the things that you need to take care of? First, you have to create the loop. Second, what you have to tell the loop that okay, you have to run 10 times. Third, you have to tell the loop that every time you run you have to print an increment of one number. So you have to define the condition for that particular loop. So let's see how we can work with loops in SQL. So I'll take a new query for this, and first let me show you a very simple loop, and then I will show you how we can use loop to create different types of options. Like for example, we'll create a table, a date table using a loop where we'll be defining the number of weeks and we'll be defining the each week to the difference of 7 days. So first let us say a simple implementation of a loop. So I'll write a variable. Now you know how to declare a variable. Yesterday I showed it, right? I'll write a declare a variable. For example, let me name this variable as counter. And the data type of this variable will be int, which is equal to 1. Now I will define the loop. I'll use a while loop over here. The while loop will say this variable counter that you have to run till you reach 25, and the counter starts from 1. So you have defined the initial position of the counter as 1. Now this while loop is saying this variable that okay, you have to run till you reach 25. Now you have to use the begin word to start this loop, and when the loop will start, it will print this variable counter. Oh, till here I am sure you are clear. So you have defined the variable which will start from 1. You have defined the loop over here which is telling this variable that okay fine, you have to run till 25, you reach 25. Now every time you will run, you have to print the value of this variable. So the first time if the loop runs, it will come and check the counter value is 1. 1 is less than equal to 25, right? So it will print 1. Next time the loop runs, the counter value will change to 2. But how will this particular counter value will change to 2? We have to also set that particular command also, so that every time this counter gets print, this variable value gets print, the value of the variable will increment automatically by 1 by writing the next command. So we'll tell set this counter equals to counter plus 1, and then we'll end this loop. That's it. This is a very simple implementation of a loop. Just an example. The next example will make things more clear for you. So we have defined a variable with a value, the starting point. We have defined the loop that it will start from 1 and it will run till 25. And every time it will run, it will print the value of that particular variable. And after printing the value, it will increase the value of the variable by 1. And now if I execute this particular, you can see that I have got a result which is run till 24. If I write it less than equal to 25, let's see how it works. It will run till 25. So let us understand. So first the value of counter is 1. 1 is less than 25. Yes. If it is yes, it will print 1. Then the value will increase. 1 plus 1, 2. Now counter will become 2. So 2 is less than 25. Yes, it will print 2. Then it will increase to 1. That is 2 plus 1, 3. The counter value is 3. 3 is less than 25. It will print 3. So you can easily print 1 to 25 using a loop. Now how we can use this loop function? Create a table. That table will consist 2 columns. First, the week number, and second, the start date of that week. For example, week number 1 will start from, for example, 1st Jan 2019. Then week number 2 will be 8 Jan 2019, because 1 week will be added to the first week. The third week will be 7 plus 7 plus 7, that is 8 plus 7, that will be again the next week, 15th maybe, third week. So how we can create a week wise? So there will be 52 weeks, for example, and each 52 weeks have a start date. So we can do this kind of options using a while loop. How? So let's take a new query for this. So let's define this particular operation into 4 steps. The first step will define the table and the column names of the table. So we can write as a, how we can write it? We can write simple, declare date table. You can write it as a date, or you can write as table date, like this. So define a variable and a table which will consist of two columns. So one we can name it as week number and the data type should be int, and week date, the data type should be date for this. So the first step is done. We have defined a variable and a table with two columns. The second is defining two variables. The first variable will hold the value of the week number in integer format, and the second variable will hold the start date of the week. So I'll come to the next line and I will declare two variables. Declare the first variable as number, whose data type will be int, and it will hold an integer value 1. This is the first week of the number, that is the week number which will start from 1. The second data type, the second variable will hold the first week. So we can name it as week first in a date format. So data type will be date, and let me start the date as 2020 12 31st. So we have declared the variable over here also. So second part is done. So the first variable will take care of this week, which is in integer form, and the second variable will take care for the date, which I want to be start from 2020 December 31st. Now what will happen? The output will start from the first week of Jan, because the loop will execute and will add 1 week to this existing week, the starting week that I have defined over here. So let's work on the main part of the loop. Now we will define the while statement. We'll come over here and write while this variable num that I have defined should be greater than -1. So anything -1, greater than -1, that will be 0 or 1, the loop will execute. So I have defined the loop rules, and now let's define the loop body. The loop body will start with begin, as I showed you earlier, and it will tell that insert into the variable date, where we have defined two columns, wnum and week date. And we'll select the variable num and we'll add a new week with the help of date add function, which takes 3 arguments: the week, the variable, the number of the week that we have defined through the variable, and the variable week first, which consists the date. And we'll increment the value of the week by 1 every time. So if week starts from 1, the second week will be 2. So num equals to num plus 1. Now we can end the loop. Now if I execute it, so data has taken a week from, and if I execute it, let me see how it works. Okay, so and I insert. The selected instance contains fewer items. The number must match with the number. Week number, week date, data has taken. Number, date table, date, select. So let me check it how it runs. What if I select star from table name? Sorry, an error. Just a minute, let me check the week number, first week. Number int has been declared. Int equals to 1 first.
number while number is to this one. Okay, let me get a condition where this condition gets fulfilled is greater than 52, then you have to break it. And now if I use this, just let me check guys, I'm missing some things over here. So date, declare the date table, define yes. That's what I was not getting. What I was missing over here. Okay, fine. Let me if you execute. Yes. So you can see that I have used a while loop statement to define the week number and the week date for each of where each of the week number there is a new week that has been added which starting from 7, 14, 21, 28. So 7 days are getting added for each of the week number. So this is how we can use a while loop. So I just missed a comma over here. That's why all these things happen. Fine. So the thing is that let's understand this particular code. So first I have defined a table over here. I have defined the tables with two columns, and then I have defined two variables which will take care of all the initial values. So the first variable take care of the initial week as 1, and the second variable has taken care of the starting week as it should add 1 week to the existing start date. Now what I have defined the condition of the loop that should be always be in positive, not in terms of minus or anything which is there to -1. And then I have defined the body of the loop which will insert into the table under the column week number and week date using this particular variable and this date add function which will add 1 week to the existing week date that we have given, and every time a week is added the week number will increment it by 1 and it will run till it reaches 52 weeks and then it will automatically break. So you can see with the help of a loop function, we have just created a table which consists of the week number and the week date. So this is how we can use a week number or a while loop to work with the table level where you can insert data, we can also select or extract the data. The next example that I'm going to talk about is also again a discussion on some operators like union, union all, intersect. What is the difference between intersect and inner join? Now let us first understand with the help of an example. I'll take a new query and I'll take a table like department table. So I'll write select star from department and I execute it. So you can see there are 11 columns, right? Now what if I again execute this particular table? You select this two and you can see I've got two results. So two different results showing me the same output. Now what if you want a union? I want to apply union operator between these two tables. Consider this table as two different tables. Now if I use union over here and I execute it, it will always return me all the unique values from both the tables. But if I use union all, it will return all the duplicate values. It will not filter the duplicate values but will return all the columns from both the tables. You can see 1 to 11 from the first table and 1 to 11 from the second table. So if I remove the all, it will filter the duplicate values. Now if I use all, it will not filter the duplicate values from both the tables. These are kinds of operators which you can use. The same like we have intersect and inner join. The inner join, what it does, it will only give the columns which matches the matching criteria. But if you use an intersect, it will also give the same matching columns, but it will always filter the duplicate, and inner join will fail, which
inner join will fail to filter the duplicate from both the columns, both the tables. The same way we are using union and union all. You can see over here. So these are some operators that you will come across while working sometime. Now these terms are very extensively used by the database administrator when they work with table structures and all. But at the data analyst level, you will mostly be using this kind of operations for joining or selecting some particular rows from the table on the basis of some use cases. Now, after all these things that we have learned till now, one important thing that come into mind again from the database administrator point of view, that how we can improve the query performance. Now, to be very frank, as a data analyst, I have never worked on query performance because I'm morely into the extracting and data and querying the data to get it in the Tableau or get it into the Power BI. But okay, I have got a request that I need to speak about some query performance. So in order to improve a query performance, now I'll leave it to you. I recommend you guys to explore these particular options for improving query performance. We can use the concept of index. The index is a very important concept in SQL Server database understanding, where we use index option to increase the performance of a particular query. Now there are a lot of questions that comes in the database industry, that how we can improve a query. Now why does the performance of a query get hampered? This is the first question you need to identify, and then we need to work on the solution part. Why the query process becomes very slow? There are various obvious reasons for a query to run very slow. First, it can be the size of the data that we are handling. It can be the design of the database that can hamper the query performance. It can be the busyness of the server that hampers the performance of the query. The server may be very busy. You're querying a request due to the business of the server. Your querying is running slow. You might be handling a huge amount of data where you are trying to extract a particular information to a query, but the query is running very slow. Or it may be a bad database design which is created by the database administrator, due to which you are facing this issue. Now the question is, let me give a real world example. Now we can take care of the query of performance with the help of index. Now what is an index? Now for understanding index, let me go back to an example on a daily life. Now when you read a book, you can see there are a lot of chapters in a book, right? Like in the beginning of each book, there is a section called index, where you can see the page number related with each of the topics that are being discussed in the book. So what do? You directly come to that particular page, an index page, you see the topic name, you see the corresponding page number, and you directly go to that particular page without wasting your time by querying through all the pages and all the chapters of the book, making the process a bit slow. You directly reach that particular page and you start reading the intended topic that is available in that particular page number. The same concept we use in SQL Server, and what we call it's called index. Now let me show you a simple implementation of index, what we do at the backend by the database administrator. So I am not a database administrator, but I have tried to make this thing very simple for you. What I can do, let me write a small query over here and let me try to explain you how it works. I'll take a new query. For example, let me write select, and I'll write count the distinct ID from the column SID employee. Let me realize it as payroll, or you can name it as pay EMP pay. I can take it from this table. Let me see. Payroll dot employee payroll. And let me define a condition where, let me check a column from here. So let me take a pay date column. So where pay date and if I execute it, I might be getting an error, not getting an error, I'm getting a value as ENP underscore 0. Now, if I select this particular command, you can see there is a option over here, just beside this particular parse option, that is estimated execution plan. Now, if I execute this particular option, you can see some values are being generated over here. Now, out of these values, this particular, these parameters that are generated below, if you focus on the last parameter, there's an option over here called table scan, which shows 96% in terms of cost. The cost over here is not the cost related to the monetary value. The cost over here is the parameter on which a table is scanned. So you can consider it as a time, or you can consider it as a number of what you can say memory uses that we are taking. For example, just make it very simple for you. So we can see over here it's 96%, which we in terms of the database terminologies, it's not a good option. Let's consider 96% is not a good time or a good resource or a good memory allocation that system is taking to scan this particular table. So what is the goal? We have to reduce this 96% to any other the lowest of value where the table scan value reduced from 96% to any other next lowest value. So how we can do that? We can do that with the help of index. So there is a folder over called index, right? Now what we can do, we can use this particular folder to index this particular table that we are using over here. Now I can right click over here, click on new index. Let's go for the non-clustered index option. And you can see that table name over here, employee payroll. Now what I can do, I can change the index name into test 1, for example. And to index this particular table, I have to use these two options, index key column and include column. In the index key column, let's add a column as pay date and click on OK. And include column, let's add a column as SID employee, for example. So we're indexing this particular column, pay date. I want to include this column for indexing SID employee. And if I click OK, you can see the indexing has just taken place over here. And now if I again execute this particular column, and if I check the execution, you can see the cost has reduced to 22% with the help of this index, which was earlier 96%. So you can see the CPU cost, this estimated number of executions. You can see how the system resources are being used for executing this query. Now I will recommend people who are interested in improving the query performance to understand this index part of querying your queries, or writing your queries, or executing your queries in a SQL Server. So this is the roadmap that I can give you where you can start to understand how we can improve the query performance by using the index options. There can be a lot of implementation of index like clustered, non-clustered. So you can use this kind of options, this execution option, to understand it more further, to understand how we can improve the query. But make sure whenever you're dealing with kind of query performance, keep three things in mind: the database design, the server productivity, and the amount of data that you're using. And you should always relate to the index in the real world that we use while reading a book, and how we can implement that particular index in terms of improving the query performance.
A very important term, a very important, you can say, feature of SQL Server. Normalization is a process of restructuring the relational database. Now, in this particular session, I'll be specifically talking about the types of normalization, how we can normalize a table in a step-by-step manner. I'll start the discussion with the definition, and then I will discuss the type or the categories of normalization, and then we'll see how we can implement each of the normalization with a hands-on example. So let's see what is normalization. Now, as per the definition of data, normal forms. These normal forms are what? Normal forms are nothing but the rules and regulations. Now this can be implemented by creating a new database, or it can be implemented by improving the existing database. So normalization rules and regulations by which we improve we restructure the database to make the queries more and more flexible. Now the process of taking database design and applying a set of criteria and rules, what we call is a normal forms. Now there are various categories of normal form, like first normal form, second normal form, third, fourth, fifth, sixth. Now the question is what kind of steps we take through normalization to reduce the data redundancy and increase the data integrity. Now data redundancy means multiple occurrence of a data in multiple tables in a database. Now let me give you an example for that. I repeat, data redundancy means multiple occurrence of a data in multiple places in a database. Now for example, if you have a sales table The sales table has a customer ID, customer name, customer address, sales. Now, for each customer ID, there can be multiple transactions, right? A customer can buy multiple times in a day for multiple products. Now, for each transaction the customer makes, the address of the customer is recorded into the table. So there is multiple address for the same customer, for the same ID. So this multiple occurrence of the data in a database is what we call data redundancy. And this in terms affect the data integrity, means the data consistency, the data security. It's not a good practice to every time the customer makes a purchase and the address of the customer is getting recorded again and again. This kind of problems is solved through normalization. Now, there are various categories of normalization. Actually, normalization is nothing but the best practices of working with database. There is nothing that you have to learn any other script or any other queries. We will be using the same data query language, data manipulation language, data control language, or data. Normalization is nothing but some of the best practice by which we can make some effective tables. Now, these first, second, third normal forms are nothing but the different categories of normalization by which we can make a table more and more robust and more simplified, reducing the data redundancy. Now, let us first discuss the first normal form. Now, in your screen, so every normal form has a set of rules. Like we have in Constitution, Article 365 has a set of rules, Article 367 has a set of, Article 377 has a set of rules. Similarly, we have set of rules. Now, only when those rules are satisfied, only those rules are fulfilled, then that particular, and only then we can apply the second normal form. For applying the third normal form, the table should be already be in a position where the second normalization or the second normal form is already applied on the table. Now let us understand it through a very simple example. The first normal form, the rules are each cell to be of single value. Entries in a columns are of same type and rows are uniquely identified. Now if you see on the example above, the example above is not fulfilling the first normal form. So what we can see that first, so this is a sales table where we are dealing with a gaming product, where we can see the manufacturer of the product is Microsoft and the product types are called Xbox and PlayStation, which are purchased by some customers like Alan, Roger, Ivan, and Alan Smith. Now what happens along with these particular products, there are certain news for each of the products. Now we can see that some customers have purchased multiple products, like Wilson has purchased Xbox and PlayStation. Now over here we can see there is a multiple products which are marked against a customer. Second, we can see that there is a data redundancy in the shipping address, where we can see that 47 Campus Road has occurred twice, once for Roger and the other for Alan. And we can see in the supplier column, against Ivan, the supplier is wholesale and the supplier phone number is a toll-free number. Now, as per the rules of the first normal form, each cell should have a single value. Now, over here we can see newsletter column against Ivan, there are two values. There's not a single value, Xbox news and PlayStation news. So this is not fulfilling the criteria of the first normal form. Second, entries in the same column type. Now, if we apply a first normal form on this particular sales record, the output should look like this. Let me show you the output. You can see each sales to be single valued. So you can see over here for the newsletter where there were multiple values against Ivan. Now Ivan, we have assigned a customer ID first of all, and each of the cell now has a single value. Instead of wholesale in the supplier column, for Ivan we have the
name of the actual supplier, that is Microsoft and Sony. Instead of having the toll-free number in the supplier phone number, we have actually given the actual toll-free numbers for Microsoft and Sony. So we have normalized this table with the implementation of the first normal form. Second, each entries in the columns are of the same type. Now over here, before normalization, the supplier column, the column type entries were not same type. You can see instead of phone number, it was written toll free. Instead of supply, it was written wholesale. Now you can see all the columns, the values in the columns are of the similar type. Third was rows uniquely identified. So we have to add a unique ID, which we have achieved by adding a customer ID. So we have fulfilled the first criteria of normal form to reduce the data redundancy. Now we can identify each of the customers with the help of a unique ID. Each of the rows can be uniquely identified. Each of the columns are of same type. So this is how we can establish. Now these all things can be easily done with the queries which we have learned. By writing the correct query, by extracting the correct table, you can apply the normalizations over here. Now I will use the second normal form. What is the second normal form? So I have taken the output of the first normal form in the second normal form, and I can further normalize this table. Now what is the second normal form? The table must be already in the first normal form, and all the non-key columns of the table must be dependent on a primary key. Now what is a non-key column? Now for example, if you take the price column over here, there's a price column. Now what the second normalization says, that the non-key columns of the table, now apart from the customer ID, the rest of the section of the table is a non-key columns, should be dependent on the primary key. Now for example, we cannot define the price on the basis of the customer name, right? So second normal form rules states that all the non-key columns of the table must be dependent on the primary key. Now over here we can see the price, if we say, is a non-key column. Now we cannot define a price, we cannot decide the price on the basis of a customer name. We cannot sell a product on the basis of a customer name, right? It's not the right way. You cannot sell a product a different price for Alan, a different price for Roger. You cannot define the price in terms of the customer name. So what we can do, for each of the customers, to maintain a uniform price, we can apply the second normal form, by which we can create a different table where we can create a primary key in terms of the product, and then we can define the price against that product. So there is a separate table which will only hold the price of the product against that particular primary key. So earlier we can see in the right hand side, we have created a table with a customer ID. Now what we have done, by applying the second normal form, we have further created a new table which will only hold the price against in a different table where there is a primary key in terms of the product name. So you can see this particular table has been further normalized in terms of a different table which only separately holds the price of the product, and there is no redundancy over here. We can see all the products price are unique in terms of the product name. So the second normalization has been applied. The third normalization states that you should eliminate the field in a table that do not depend on the key. That is, if you talk about this particular table, the primary key table in the right hand side, the price table, you can see if there is further redundancy of the data in the supplier phone number, where we can see that two phone numbers from the same supplier has been repeated twice. So again, there is a data redundancy over here in terms of the supplier or the product or the price table. So we can apply a third normal form where we need to eliminate the field in a table that do not depend on the key. So what we can do, this particular phone number is not dependent on the item key. We can create another separate table. And what is that separate table? You can see over here, another third table created, where I have created a primary key in the names of the supplier, Microsoft and Sony, and we have created one more new table that holds a unique phone number. There is no phone number data redundancy in terms of the supplier phone number. So the third normal form fulfills that you should eliminate the field in a table that do not depend on the key. So these phone numbers are not dependent on this particular product key. Actually, this particular table, the prices are dependent on the primary key. So what we have done to reduce the data redundancy in terms of the supplier phone number, we have created one more table in where we have made the supplier name as a primary key and the phone number as a value of phone number, where only one unique number has been updated against the supplier name. I'm just showing you the practices that we can follow through an example of the first, second, third normal form. So we have also fulfilled the requirement of the third normal form. The next is the fourth normal form, which is no multi-value dependencies.
Now, what is the multi-value dependency? If you concentrate on the table, customer table, you can see that the address of the customer, that is 47 Campus Road, Boston, and 47 Campus Road, Boston, has been repeated twice over here. So again, there is a data redundancy in terms of the shipping address in the customer table. Now, what we can do by applying the rules of the fourth normal form, which states no multi-value dependencies, we can remove this. We can also control this data redundancy also. How? We have created a different table in terms of the customer, where a single customer name has been updated and all the addresses against that particular customer has been updated against them. So this is a different table for the address of the customer. And now when we apply all the normalized features for starting from first normal form, second normal form, third normal form, fourth normal form, this is the final output, the full normalized table, which we started from a single sales table. So we have a customer table where the primary key is customer ID. We have a subscription table which holds all the subscription details against the customer ID. We have a sales invoice table where we have the customer ID and the items. We have an item table and we have a supplier table. And each tables are interrelated with each other with many to one kind of relationship. So we started with a single table, with a sales table, and by applying the different forms of normalization, we have seen that how we have reduced the data redundancy, and we have created certain best design of the database where we can work with single or unique value of data. Now, if there is data redundancy in your table, what happens? The use of update, alter, delete queries increases a lot, which actually increases the amount of queries also for that database or for that table, which is not a good practice in terms of working with SQL. So to reduce those kind of what you can excess querying of your table information, the concept of normalization was introduced while working with SQL.
I hope I was able to clear all the concepts of the discussed topic with what I planned for today's agenda in terms of the SQL Server. Now, the best way to learn this topic is to just practice and try to implement these concepts with some useful case studies or useful business scenarios. I hope these topics were quite elaborative, and I tried my best to use some hands-on example to make things more clear for you guys. Thank you for watching this video.